This conference will now be recorded. This conference will now be recorded.
So hello everyone, welcome to day 11 in our GCP Cloud Architect training. So last week we started exploring about the concepts about Kubernetes, why Kubernetes came into picture, and we also started doing a little bit of a demonstration where we provisioned Kubernetes using a graphical user interface. Using the UI, we just went and created our stuff. And in 1 week, there is a good enhancement, which I'm going to talk in the next few minutes. So we created a Kubernetes cluster. We deployed a workload, and we also exposed this. So we deployed it, and we also exposed it as a service, and we were able to also look into the stuffs, the content. So this is something which we had explored last week, and we had stopped at this stage in our slides, and the slides are updated in module 3. If you go and look into it, it's up to date. So I have updated the content there with the latest content what we are going to see. So last week till here, step 6 is what we had explored. So uh, creating a Docker image, having a Docker image, building pushing it to GCR, consuming it in a cluster, everything we had seen it. So till step 6 is what we had done. And I just wanted to show you a couple of steps today where you scale up and scale up also. If I am not wrong, we had seen it. So I'll just show you that how do we do scale up and scale down of the number of pods today. And we'll try to deploy a newer version of a container and see how it's going to reflect. Then we'll move on to our basically our command line equivalent, which is the most best way when it comes to Kubernetes. So you have to always make sure you always work on Kubernetes in a command line mode. So that's a recommended way. We'll also shed a good amount of time on that. So before we do that stuff, just wanted to share some important announcement which you should have seen in this week, something called as autopilot mode. So this was not there in the last week class when we did. So when I click on create, it used to just show up a form. Now we have a new feature called as autopilot mode. So in very simple terms, if I were to give an analogy, it's like your Tesla car, where you don't need to have a driver, so it runs in an autopilot mode. It is something of the similar sort where you don't need to worry much of your what is my node configuration, all those things. You just focus only on your pod, nothing else. So as simple as it. And you don't need to worry how many nodes I should have, all those things. Today we will see definitely some issues when we have configured our nodes in a low configuration. What are the problems we will face? So by end of today, you will really appreciate autopilot mode, which has been just released last week. So I'm not sure what is the state, whether it is in beta or it is in generally available. I did not check it. But since it is something recently launched, it should be in beta if I'm not wrong. Uh, it's a cool feature. Explore it, and there's also a video in the official YouTube channel of Google Cloud Platform. Look into it. It was really cool. So 1 week you see lots of changes. So just wanted to show you that you should be always spending some time to explore new features coming there. Okay, so what we will now do is, if I go to my workloads, we see 3 pods running. So let me just slightly zoom this. Yeah. So we see 3 pods running. Now assume there is a good amount of requests coming in and you need to scale it up or scale it down. So how do you do it? In the UI. In the UI. So just go to your deployment, which you have done. Under workloads, if you go, you will see something called as deployment. Okay, this is better to go to this page. So go to your deployments. So this is running on GCP itself, so it's going to be much faster. So go to your deployments. You see currently 3 pods are running, 3 identical instances of the pod are running, and you want more. In the UI, you click on that deployment and you have an option under actions. So if I click on actions, you have an option auto scale. We'll talk later. So we have an option called as scale. If I do it as scale, it shows the current number of copies which are running, replicas. So you want to make it 4, you do it 4, or you want to scale it down, you scale it down to 2. So let's scale it down to 2, and you will see the number of pods going to come down. So if I go down, there is one pod which is getting terminated in next few minutes. It's going to get terminated and you'll be only left with 2 pods. And if you want to scale up, same thing, come to the actions, scale, change it. So that's how you do it basically when it comes to scaling it up and scaling it down. And this is done manually, folks. This is done manually. And if you want to do something automated, you are going to use something called as HPA, horizontal pod scaling, where you are going to mention what is the minimum number of replicas you want, maximum number of replicas, and when you want to have a more. So you'll have a metrics. So when my CPU is hitting 80%, create a new pod. So that's what you're going to do. And you can go up to 5 replicas. Afterwards, you cannot do anything much. This is what you do basically at a HPA. We will do this demonstration in the command line. It's going to be much easier to show it in command line rather than in UI. So you have to, we'll just put this on hold, the HPA demo in our command line. So if I just go back, refresh it, the pod should have been deleted and we should be left with only 2 pods. 2 pods. Now if I go and serve it, it's going to show me the same thing, no changes. It's only going to be served by 2 pods basically. How much it can serve, it can do it. Now if we go back to our slides, what we have seen is scale up and down. So the same option in the UI, just go to on the specific deployment, click on actions, and you can scale it up and scale it down. Now the last option is, I don't want to see this boring screen, welcome to containerization. At least change it to something. One text, change the textual content. So it's a new version is what you are expecting. Now, how do I deploy a new version in GCP in the UI mode is what I wanted to show. And we are going to repeat the same thing in command line also. So I want to have something like welcome to containerization version 3.0, something like that is what I want to do. Let me show you how do I do that. So for that, make sure you go and check your GCR. What is the version which has been currently deployed? Sorry, better to see it here. In your workloads, if I click on my deployment, it's going to show what is the current image you are using. So what is the current image you are using? It's going to show the details. So I have to recreate it during the morning time. So it is nothing but our version 2.1 last time which we deployed. So if pushed actually, so if I just go to my GCR container image, I'll put it in a new tab. My app, it was 2.0. This is what I deployed currently. Now let's try to deploy 3.0 and see whether we are going to see that message here. Okay, and the kind of deployment which we are going to do is called as rolling update. Again, more on this when we do it in our command line. So the only focus now is how do we change it to a newer version, and if there's some issue, how do we roll back in the UI itself. Let's try that. So for that, I should have a new image, right, which is going to have welcome to containerization 3.0. So for that, I have to touch the code, server.js file. I have to touch it, change the content, do either Docker build and Docker push, or use cloud build option, G cloud build, submit. that option you can do. So either one is fine. So what I'll do is,
Doing this when the system is running.
Sorry, it's going to be up. There's no downtime going to be. So you're going to see it's a rolling update. So you will have one pod running, and the new pod is going to update it, and the older pod is going to go off, and you should see the change reflecting it there. So zero downtime mostly.
Thank you.
Yeah. So what I will do is I'll go to my folder where architect container node.js. So this is my file. So I'm just going to edit this. So this is where our source was there. So welcome to containerization version 3.0. Not much change, but just to see there's a content change there. So save this file. That's it, which is going to be done by a developer. Now, we will look into the same kind of demo when we do in our module 7 on CI/CD process, all those things. This entire process can be automated. A developer writing a code, committing the changes to a repository, it's going to automatically update the version in Kubernetes. All those things are going to be automatic. But now we have not gone to that stage, so I'm going to do manually. So meaning I'm going to do something like gcloud, something like this. So gcloud builds submit, and version which I wanted is 3.0, or docker build. I'm going to do it manually. So let's do it. So this is going to build my container image and also push it to GCR. Once it has it, I'll show you how do we do it in the UI. The UI why I'm showing this is just to make you comfortable how things work, and later we'll jump. Today the entire remaining session is going to be only on command line. So I'm going to go also a little slow so that you get it. And there are certain commands which can be asked in the exam. Few things which I have seen, I'll definitely highlight you. These commands are important so that you can focus little more on those things. So the image is created and built. To verify it, let's just go and refresh it. We should see 3.0 and it should show just created, something like that. Did I create it in or push it to the right? It's not showing. Let me just refresh it. It's not showing. Maybe then the project which I pushed was wrong. Let me just echo my project. That was the only stuff which is going to decide to which project I'm pushing it. I'm on the right project. Anything wrong? Oh, what was the name I gave? Sorry. What was the name I gave? Okay, my bad. I should have done my app. It created a new this thing itself. So hello demo. We don't want this. We don't want this. So I'm just going to delete it. Let's keep versions of the same image with the same name. I made a mistake there. Sorry. So we'll go with my app itself with the name. Let me do it one more time quickly. Anyway, this build time is going to be free, 120 minutes free. So there's nothing we are going to lose here, and we are not going to pay anything extra. Done. This time it should show up. Refresh. Awesome. Just now 3.0 has been deployed. Now, how do I change this so that it's going to show that new content? Now, if I just refresh it, nothing is going to show. It is going to be the same thing. How do I do it? Basically, I go to my deployment. I never done much in the UI, so let me just check it out. Automate, yeah. So I can just click on edit. So in the UI, I know only one way. So in command line, we have multiple ways to do it. So let's look into the command line UI. In the UI, if you click on edit, it's going to show you the YAML file, and one of the line which is going to be, and there are lots of auto-generated content, so let's not worry much about that. The one which is of important for us is line number 113, where it indicates what is the version which you are serving. So I'm going to mention it as version 3.0. That's it. This is the only thing which I'm going to do, folks, nothing else. So we know what is the version, what is the image, the complete details of this. You just put it, that's it. It's going to work. So to do the changes, click on save. Now when I do this, what's going to happen is it's going to do a rolling update. What is rolling update? I'll show you when we do the command line demonstration. It's going to be much easier to see it. What is going to happen behind the scene is a new pod is going to get created with a new version. So once it comes up, once it is up, this is the new one. The older one gets terminated. Now if you just go to your link and refresh it, it should show your stuff. Downtime, zero downtime, literally. So the older one goes off, the newer one comes up. That's it. So the older one is going to be staying, the older pods are going to still stay till the new one comes up. It's like handover, basically. So once that is handover is done, the older one is going to get terminated and you have your newer version. Now in reality this will happen. Now the customer or the manager will come, can we roll back? Something gone wrong, we want to roll back, no problem. In Kubernetes this is what we can do it very easily, and with the concept of containers, rolling back, managing better management of versions, you can see it. If they say please roll back to the previous version, so easy. Just go again, edit, change the version, and now you will really appreciate the value of versioning. Where's that line? The value of versioning. So if I just slightly zoom this, yeah. So the value of versioning, you want to make it 2.1, do it, and it's going to reflect back. Maybe you can keep checking this in the chat. I'll just put it in the chat if you want to check when it's going to change, but you will never see a downtime. You can keep hitting it, folks, just for your confirmation. So let me just see whether I have changed it. Yes, 2.1 is what I have changed. I'm just going to click on save. When I click on save, new pod is going to be created. Container creating. The old one is still there. Now if I just refresh it one more time, the old ones are going on and the new one is coming up. Now if I go, I should get just welcome to containerization. That's it. Did anybody see a downtime, folks? Uh, I would say no, you'll not see a downtime. So it's going to be very seamless rolling update happening. So this is how you can do different versions easily in Kubernetes. So we have finished all our 5 steps or 8 steps in our demonstration. Last 2 were left last week, so I thought I'll finish it. Everything was done in UI. I never went into any complex Kubernetes commands to make you comfortable in the beginning. So any questions till now, folks? Anything on command line, we'll definitely answer it later, but in the UI, what we did in today's class, any questions on it? So any questions? We just did 2 steps: scale up, scale down based on, you can also do auto scaling, easier to explain in the command line. Good. So if it's clear, the next part is going to be basically, we had seen this, what are the various different types of auto scaling. The next option is same set of stuffs, but you do it via command line, CLI. Now for CLI, there's going to be one powerful command which you're going to use in Kubernetes called as kubectl or kubectl. Different people call it in different ways. This thing. So I have seen Googlers talking, mentioning usually as kubectl. I usually use it as kubectl. It's your choice how you want to spell it. Different people spell it in different way. So that's a very, very important one when it comes to interacting with the Kubernetes cluster in the command line. So anyway, we have a Kubernetes cluster in the UI, right? So let me just give you a hint. How do you connect to this cluster in the command line and do all those things? So to do that, if I just go to my command line, so I'm just going to close this. Okay, if I close it, okay, it's okay. Let me open my Cloud Shell. The command line which you're going to use heavily from now onwards is called as kubectl or kubectl, whatever you want to call. So when I just do this, hit version, it should show what is the version, all those things, blah blah blah. And at the bottom it shows something, cannot connect to stuffs, all those things. So if it shows like this, it's an indication that it is not connected to any Kubernetes cluster. It's an indication of that. Uh, Usually I run this command to check whether I'm able to connect to my cluster, because we know whenever you create a Kubernetes cluster, it is at the end nothing but groups of virtual machines which you create, managed instance group. Now, how do I get those node details, all those things? I run this command get nodes. If I can get a result, it indicates I'm able to connect to it. If I don't get a result, there is something wrong, basically is an indication. So usually people start creating the cluster in the UI and they directly go and run kubectl command. It's not going to work. The reason is you need to get the right certificate, only then you can work. So where is the certificate going to be there? So to get that certificate, there's a command which you need to run, and that command is going to create a copy of the certificate in your system. The system where you're going to run kubectl commands. So in Cloud Shell, oh sorry, my bad. In Cloud Shell, you're going to have a folder called as .kube. Inside this .kube, you will have a file called as config file, which is going to keep all your Kubernetes configurations, the certificate, all those things to connect and interact with it. So this is going to be cached and you can easily use it. Now what's happening in my case is I created this cluster, everything in UI, like the way we did it in last week. So everything in the UI, so it has no clue how to connect. So meaning there's no information in the config file. So let me just show you how the config file looks like if you are very curious to see. Uh, I can use edit config. This is going to launch our uh, editor called as Cloud Shell Editor, which is going to be very, very handy in today's class. So you'll see some entries, lots of entries, lots of servers which I would have worked. All those entries, if I have created something in the command line, those entries would be there. Or if I have connected to the cluster, I'll see those entries. Now, I don't understand this. I don't understand these things. So what I will do is I'll clean it up. I don't want this folder itself, .kube folder. I'll clean it up. So rm minus rf .kube, completely wiped off. Nothing is there. Now if I run kubectl get pods, sorry, get nodes, the number of nodes, it's now going to show the connection to the server localhost 8080 was refused. If you don't have any entry of kubeconf, the configuration file which I told, it's going to give you an error like this. So whenever you get this kind of an error, it's an indication that the config file is not there. what you should do is basically go to your Kubernetes cluster, click on these three dots, and you have an option like connect. When you click on connect, it's going to give you a gcloud command where it's going to get the credentials. Copy that. This is the first command which you have to do when you have provisioned a Kubernetes cluster in the UI and you want to connect to that cluster in the command line. This is the first step you have to do it. So, and when you get this kind of an error, the first thing is see the connection is there or not. So it is now thinking like in Cloud Shell, there is some Kubernetes cluster running on port 8080 and it is trying to get that. But we don't have anything running in our Cloud Shell. So we want to connect to this Kubernetes cluster, get the credentials. This is our cluster name, the zone, and the project. So now when I do this, what's going to happen basically is, let me just Control C. When I do this, what's going to happen is I'm going to have a .kube file created. Sorry, folder, and inside that folder, config file is going to be created, using which only we can get all the details. So let me just paste this command, and it's going to get my credentials. Fetching cluster endpoint. This is the master node's endpoint, the external IP address with which the API servers, all those things gets interacted. Kube config entry generated for this cluster. So what it means, if I put ls minus a, I will have a file folder called as .kube, and this is a hidden file. That's the reason I'm using ls minus a. Now if I go inside this folder, you should see a file, and if you wanted to get the details of that file, so you see this is my details. So what is this server? This is nothing but your this Kubernetes clusters master nodes masters endpoint or your control planes endpoint. How do I verify it? Ending with 73. Just minimize this. Go to your cluster. You see this? And the entire certificate is going to be given to connect to it securely. So that certificate is also going to be there here. Somewhere here it should be this one. This is your certificate. So you have the complete picture of the certificate. Now you can run any kubectl or kubectl commands easily. So I have an entry of, now tomorrow if I have one more Kubernetes cluster, even that entry is going to be created here. So now since you have got the credentials, if you run kubectl get nodes or node, whatever it is, all the options I'll show you. Nodes, it is going to show there are 3 nodes. These are nothing but your virtual machines. How do I know these names are correct? Let me just do this. Yeah. How do I know the names are correct? Simple. Just go to your compute engine and you should be able to see those stuffs. The 3 virtual machines which got created because it's a 3-node Kubernetes cluster. So 3-node Kubernetes cluster. You see end with 37, 8S, 4J. That is what you got it here. And it also shows the version of your Kubernetes running. There's one question, can you show where did we get this command? Sure. So if I go to my cluster, so if I go to my cluster, you have these 3 dots, vertical dots. Click on this. You have an option called as connect. So if I click on connect, you will get this command, copy it and do it. And this is the first step which you have to do if a cluster is created in the UI, or you're working on a cluster where somebody else created it and you need to now run on a command line mode. You have to do this, connecting it. So as long as you have the right credentials, you should be able to get it. So hope that clears your question, Vijay. So just click on this 3 dots, you should get it. Or if you're already in the cluster page, you also have an option like a connect. It depends how you want to do it. How to create a cluster in the command. We'll come to that. That's the next demo which I'm going to show you. So first I wanted to clear everything in the UI. And thanks Anil that for those comments. So looks like the concept is clear. Thank you. So because this is a lead, this is like your a sequel which you are going to have. So you have a movie which is a successful movie, the next version of it. So you are going to give us a trailer to that towards the end, right? Something like that. So everything is going to be using command line. So to know how to play around with the command line, you need to have this kubectl stuff. Extensively, we are going to work on kubectl commands now. Now what I'm going to do is I don't need this cluster anymore because I created it in the UI. I don't want it anymore because the next demo which we are going to do is fully on command line. We are not going to even look into the GCP console. Everything is going to be in Cloud Shell. So we will not delete the cluster using kubectl. One important thing is there are two commands which you are going to use very heavily. Kubectl. This is only to interact with your cluster, folks. Thanks Anil Kumar for bringing this. So when you are interacting with your Kubernetes cluster, you are going to use kubectl or kubectl command. When you want to do something with the infrastructure, basically the cluster itself, upgrade the cluster, increase the number of nodes, all those things, you have to use always gcloud command. This could be also a possible question. So which you will get it cleared because whatever you do, it has to be in the command line. Okay, so you have to use it in gcloud command. So since we created this cluster in the UI itself, let's try to delete in the UI itself. Uh, Later, when we create one more cluster in the command line, we will delete it in the command line. So this one, last option, delete it. That's it. So the remaining next 3 hours or 3.5 hours, whatever it is. So it's going to be fully in command line mode. So command line mode, and we'll see lots of commands, and everything is documented. Um, and I'll highlight you what command could be important, at least from the exam perspective. So I would say at least 20% of certified Kubernetes administrator or developer concept is what we are going to learn. So slightly some few things could be advanced, but I wanted to cover as much as possible the concepts. The focus is more towards exam, but few things. There are some simple concepts which does not make very clear. I'll try to make sure I cover it to the extent. So this cluster to create. What we now do is create a now is command line interface, graphical user interface, command line interface, everything in Cloud Shell. I'm going to do it. If you want, you can do it also on your local laptop, Windows, Mac, whatever it is. If you are having your kubectl command installed, the cloud SDK and kubectl installed, you should be able to do it. Now what we will do now is we'll create a Kubernetes cluster in the command line, and we are going to create it in such a way that we will see auto scaling, node level scaling, pod level scaling, everything we are going to see it. So for that, what we'll do is we'll switch back to our Cloud Shell, this cluster to go off. And I would strongly suggest you to see the autopilot mode option, folks. Very cool feature. The word also was very catchy, I would say. The moment I heard autopilot, the one which was I was able to recollect was Tesla cars. So okay, by the time this comes up, anyway, the cluster is getting deleted. So for the rest of the day, it's going to be a Cloud Shell. So what I'll do is wanted to show you something here. I'm going to clean it up. ls minus l minus a rm minus rf dot cube. I am cleaning it up. Why? When I do something in command line, right, this kubeconfig file is automatically going to be generated. Just wanted to show you. Is my voice breaking, folks, by any chance? Okay, let me just see what is the issue. Okay, let me check it 1 minute. I'm checking it. Just a minute. What's the issue? How about now, folks? Is it better by any chance, or it's still breaking? Is it better? Okay, let me know if it becomes worse again. Okay, fine. It's better. Okay, small glitch is what I feel. Okay. Now, what we are going to do is I have deleted that cube file, .cube folder, sorry, not file. The folder has been deleted. Whenever you create basically a Kubernetes cluster in the command line, it's going to generate a kube config file automatically for you. So I wanted to highlight that. So how we are going to create something in a cloud shell, I'm going to use this command gcloud containers. So to create anything with respect to create a Kubernetes cluster, gcloud command. To play around with the cluster, kubectl command. Simple. Okay. So since we are going to create it, we are going to use gcloud command containers. Now, you may ask me a question. When we create something with compute engine, we use gcloud compute. When we create a Kubernetes, it should be gcloud Kubernetes, right? I would say if you have that doubt, I'm also with you. The reason is it should have been gcloud Kubernetes cluster, something like this. But what Google has done is they kept it as containers. Yeah, or GKE, something like that. GKE container clusters. This is what they have done. The reason is, remember the last week's slide when we saw Kubernetes introduction, it was previously called as Google Container Engine. When that product was launched, the backend team would have created a the command line equivalent of it. They have not changed it. They have changed the name, but they have not changed the command line equivalent of it. So that is the reason why you still use container. Maybe in the future they may change it or they may not change it. If somebody asks you, this is the reason basically. So they change the name in the front end. It's like how a web developer usually does. So they just change everything in the look front, but in the back end it's going to still look as an older system. So container plus gcloud container clusters create. Now, give a name to your cluster. I usually prefer to give my project ID itself as my cluster name. I'll just put hyphen CLI just to indicate it is coming from command line. So I'm going to put some extra comments here. So I'm going to have my worker nodes with a type, the smallest one which you can have, G1. You cannot create a cloud Kubernetes cluster with the node pools with F1 micro. The minimum is G1 small. So G1 small is the machine type, and I don't need a 3-node Kubernetes cluster, folks. What I need is only the number of nodes. What I need is just one node. Why I am starting with one node? I wanted to show you node auto scaling. So to show you that, I have to start with one. So with this, I should be able to create my Kubernetes cluster, and I will also put time in front of it just to know how long it takes to create a Kubernetes cluster. So it usually takes less than 5 minutes, but I wanted to show you that by putting time in front of it. So this should be good enough to create it is what I feel. Let's hit enter. So I get an error. Basically, gcloud.container.clusters.create expects region or zone must be supplied. What does this mean actually, folks? I get an error. What does this mean? What does this error mean? You should be in a position to answer this error. Yes. No, project is already set. Project is already set. So if I just do this, sorry. If I just do project, the project ID is set. The zone or region is required. So if I supply a zone, what's going to happen, folks? If I supply a zone, what is this called as? Sorry. It's going to be called as a zonal Kubernetes engine cluster. If I mention a region, it's going to be a regional Kubernetes cluster. Yes, Anil B. So either you can create a regional Kubernetes cluster or a zonal Kubernetes cluster with just one parameter change. So when you mention region, make sure you, and you can use equal to, or you can just use space. Both are going to be recognized as a value. So if it's region, you mention something like a region, which ends with a number. And also you should have a proper region name there. If it's a zone, you mention a zone there. This is how you mention, and it should get created. But we are going to run lots of commands today where we are going to rely on this parameter. So I don't want to pass this parameter again and again. Again, laziness, that's it. I don't want to pass this parameter again and again. So what I will do is, for the entire rest of the cloud shell session, I wanted to set this parameter. So if I just do gcloud config list, this is what has been set. There's no zone, there's no region. So the first day class, we had seen a command where we can set the default zone, region, all those things. Let me set that so that I don't need to pass this parameter again and again for every gcloud command. So I can use gcloud config set compute. Okay, it should be this zone. I wanted to set my zone, the default zone in my Cloud Shell till my session is live as Singapore A zone. Done. Zone is updated. If I run this command, I should see my zone somewhere here. Yeah, zone. Why I'm doing this? Laziness. That's it. So I don't want to pass this parameter again and again in every command. So if I just run the same command last time, which did not work, this time it's going to work because it's going to take that variable which has been set, the reach, the zone. Okay, so let's see whether this time it's going to work. Again, a cloud shell, sorry, a Kubernetes cluster with the name my project ID -CLI, and the machine type is going to be G1 small, the number of nodes 1, in which zone? Singapore. And we have not set any region, so it's going to make it as a zonal Kubernetes cluster. Let's hit enter. This time it should start working, and the command line is always verbose. More information is going to come. So by just looking at itself, you are going to see some stuffs uh, from starting from January 2021. There's some changes which they are saying, few stuffs which is going to be turned on by default, all those things. So, and lots of stuffs, and one of the stuffs which Vijay was mentioning, starting from version 1.19, newly created cluster and node pools will have container optimized containerd as a default node image, where no images would be specified. So it's going to basically use containerd as your runtime, not your Docker. So there are lots of changes going on. So let's wait for the cluster to get created. It's going to take around 4 minutes or so, if I'm not wrong. If I just refresh this, you should see that cluster getting created. Now, in the UI, you get one little benefit when you click on it. It shows you something like this. So what's happening basically, the status. So usually when you create a cluster, just click on the cluster name. It's going to show the progress, 67%, what it's going to do basically. Configuration is done, deployment is done, some health checks is going to be done. Okay, Once it is done, we should be able to see basically our cluster, and we can start playing around with the cluster. And because it's a one node Kubernetes cluster, if I come to my compute engine and refresh it, you should see only one compute engine, basically, with a name GKE prefixed with your cluster, with your project ID, the default node pool with some randomness as a suffix. So let's see where the cluster is ready. And this is one of the highlight, I would say. The cluster gets created very fast. Cluster gets created very, very fast, which is really a cool feature, I would say. And anyway, we have put time in front of it. We should get to know roughly a number, which is going to be less than around 5 minutes. So once this gets created, everything is going to be in command line, meaning we are going to, if I just come back to my this thing. So this is what we are doing currently, cluster creation. Once the cluster is created, I'll show you how do we deploy the stuffs, uh, how do we deploy a container as a workload in our Kubernetes cluster. And in the CLI itself, you're going to have two modes, basically. The first mode is called as imperative configurations, or you just run a command, it's going to get created, imperative. So the other option which you are going to see is called as declarative. So two approaches in command line itself. And which is the best option? Declarative. Why? I'll later, as we go, you will understand it. So first let's explore imperative configuration. So if you already have a Kubernetes cluster, the way you're going to create a deployment is going to be with a command, and don't worry about the commands. You'll get used to it once you start exploring it. So now you have the cluster. If you have the cluster and you want to deploy something into it, the command which is going to be used extensively is always kubectl. So you cannot do anything with your gcloud command to do any deployment, have a configuration change, like uh, have a new service, anything with respect to Kubernetes. Once you have infra is there, everything is going to be kubectl, no gcloud command. Remember that. So the commands which are highlighted in the yellow color are something which is important from the exam perspective. So I have seen a question on the last one, kubectl set image. What is that? I'll explore, I'll show you that during the demonstration. But these commands are at least important so that you can focus somewhat extra on these commands, basically. So once the cluster is ready, right, this is the command which we're going to run. Kubectl create deployment, the name of the deployment which you want to give, and the image. What is your image? The container image which you want to deploy, how many such copies you want, replicas. Okay, this is what you are going to do. So let's wait for our cluster to come up. Done. The cluster is up in 3 minutes 10 seconds. Beauty. Now wanted to see the same thing, whether it is created in the UI. It should be, you see that it is there. It's a one node Kubernetes cluster. I would say the smallest configuration which you can have is this one node Kubernetes cluster. Now, if I go to my workloads, you will see nothing. Last time how we did, we clicked on deploy, we picked up that image, all those things we did, and it started working. Now this time what we are going to do is, we are going to do everything in the command line. So to connect to that command line and do everything right, you need kubectl command, so that it can get the details about this cluster. Now, in 3 minutes, 10 seconds, it has created. So it's going to be very fast. Now you may say it's one node. You can add 2 nodes, 3 nodes. It's going to be almost the same thing. So uh, I see it is less than 5 minutes. I'm not a salesperson, so but I have seen it. It gets provisioned in less than 5 minutes, usually much faster. Now, if I put ls-a, the .kube folder which we had deleted before the cluster creation, now it is automatically created. Now if I go inside this and do edit config, you should see a file which is relevant to your new cluster. So this is your endpoint where you can interact with your API server ending with 139. Want to verify it? Just go and verify it by clicking on the cluster. You should get that details. So this is my endpoint. Good. Meaning what it indicates is the cluster configuration already, you have already got the credentials. You don't need anything extra. So meaning if I just put kubectl command, and this is the first command I usually put when I want to interact with a Kubernetes cluster. Can I get the details of my nodes? I can get it. So I can get it. It is the same thing ending with KB. So I'm able to connect to that Kubernetes cluster as an indication. So I'm just going to little zoom this off so that I can show you better. This should be good enough. So this is one way to get it. So the first command, whether I'm able to connect it or not, I run this command. It could be node, it could be no. These are all alias commands. You can run it anything which you like. No, nod, nodes, anything is going to work. All are alias commands. And if you are if you don't want to type Kubernetes kubectl also, in your configure in your .bash rc file, you can create some alias if you want. So I have created one alias like k. I can also do like this. I have created a config file like that, alias there. So it's going to be always persistent. If you are interested how to see that, edit where I am currently. Yeah, edit .bash rc. So I would have put a alias somewhere here. Yeah, this is what I have configured. So K, if you want to, if you're going to run kubectl command very heavily, so instead of typing everything, K if you type, it's going to create kubectl. P if you do, this is the command which I usually do to get a bigger, to get a complete real estate. I have put these alias. So it's usually in .bash rc. So if you are new to Linux, it may be something which you can explore. If you are already using Linux, it's going to be already known factor there. So my nodes are showing, that's good. Now, how can I know, is there any pods running? So to know any pods running, you use this command kubectl get nodes is to get the nodes. If you want to get the pod details, you can type pods. Nothing is there. Or you can do pod, or you can use PO. It's your choice. Anything is going to work, but nothing is there is what it indicates, basically. There's one question from Deepak Bhandari. Is the bash file in your home directory? Yes, it's always going to be in your home directory. And if you put ls-a, you should be able to see that bash rc file. Usually it's going to be in your home directory. And once you run it, you have to execute that bash script like this way. Only then it starts working. Otherwise, you have to restart it. What means no application deployed? You have not deployed any container. So if I run this command, so no resources there. So meaning it's an empty cluster. What you have is an empty cluster. No workload, Anil B. So there's no workload deployed. So you have not even deployed anything. It's an empty cluster. So that's going to give you the details what's been deployed. Nothing is there. Nothing is there. Now we have to deploy it. So to deploy it, what we are going to use is a command which we saw in our imperative configuration. This is one way. kubectl create deployment, the image, how many replicas. Let's go ahead and do it. So till here, any questions, folks? We created a cluster in the command line. It got created. The kube config file, the importance of that I have mentioned. And since we created it in the command line, the config file generates automatically, and we are able to connect or get the details of our node. And there's no pods deployed. We are going to create a deployment. So that is the current stage which we are in. So any questions on this so far, folks? And I want it to be clear. So without this, we'll not move further. So let me know if there's any questions on what we have done so far. So is that clear, folks? Anything which is not clear? Just created a command, a cluster in command line. That's it, nothing else. Remaining things automatically followed. Automatically followed, meaning connecting to the cluster became automatic because we created it in the command line. Good. Thanks for the confirmation, folks. Now, what we will do is kubectl. Now, no more gcloud commands. Forget your gcloud command. Whenever you have to do with the cluster itself, the infra, come to gcloud command. But when it is going to be inside your cluster, what you are going to do is always using the most powerful command, kubectl or kubectl. So what we'll do now is we'll do kubectl create, and it gets auto completion, folks. Create deployment. So let me call the deployment as hello. Simple. Hello. And what's the command which they have mentioned? And this is mentioned in the slides. You should be able to get it. Image and replicas is what you need to mention. So hyphen image. And what's my image path? I don't remember it. Let me go to my GCR. And we'll use 2.1 version, the older version which we created last week. So I'm just going to copy this. So I don't need this. I'll just copy this one. This is my image, and the version which I'm going to use is v21. And how many replicas I want? 1. I can use equal to 1, or I can just use like this. This is also going to work. Now, before I hit enter, right, I'm going to put a tab. I can put up to 4 tabs in my Cloud Shell. So what I'm going to do is I'm going to use this command very extensively throughout this class called as watch command. So if I do kubectl get pod or pods, whatever it is, it's going to show nothing is there. Now what I will do is the same command, I'm going to run it in a watch mode. Keep refreshing this command every 2 seconds. So every 2 seconds, it's going to get refreshed. You see this clock running. So every 2 seconds, it's going to refresh, meaning the moment I do a deployment, what's going to happen is I'm going to see an entry here. I'm going to see an entry here. So let me click on, type this, hit enter, done. You see this, folks? A deployment is happening. So you see the various status, container creating. Now it is running state. It is in a running state. Beautiful. So it's running state, and that's our container deployed as a pod. So the same thing which you did last time by clicking on deploy, doing all those things, it has been done now via command line. And the command line which we used was basically kubectl create deployment. It is created. Now if I just refresh the screen, you should see the deployment with the name hello. But we don't have 3 replicas like what we had in command line, so in the UI, but we have specified we want only 1 replica. That's it. So good. Now last time when we did it in the command line, once you have the deployment done, it was asking us to expose it to the outside world, where we clicked on expose and created a load balancer. Now, if you want to do the same thing in command line, what you do basically is you run a command called as, so what happened to my, 1 minute. You run a command called as kubectl create service. You expose it as a service. So you have to do that. Now, before we expose it, I remember one of you asked, can we see auto scaling demonstration in Kubernetes? why we were not able to do auto scaling demo in the console, in the UI, was there was a configuration which was missing. Whenever you do auto scaling, you have to mention what is the metrics, what is the specification of the pod, how much it requires, how much CPU memory it requires. So you have to give that configuration details. So when you just use kubectl create deployment, it will not capture any such information. Basically, how much vCPU, how much memory you need for running that image, that information is not usually captured. If you don't mention that, auto scaling will not be working. So this is an important option which you have to do. You have to give your CPU, vCPU, and memory specifications. And this is an important concept, and it was an interview question for me when I was getting interviewed from a very large organization, where they were asking, how do you control the specifications, the memory specification, the CPU for a specific deployment? You write a small configuration and mention what is the thing which you are expecting. For running this pod, I need 0.2 vCPU, 256 MB of RAM. So you can mention those things easily. Let's just mention this part and then expose it as a service. Okay. Why we are doing this? For our auto scaling to work, because one of the demo which we are going to do is auto scaling. So let's just edit our deployment for changing our specifications. So how do I edit my deployment? Simple. kubectl edit deployment, the name of the deployment which you created. And if you don't remember the deployment name, no problem. I'll show you how to get it. So if I go back to my this thing, so if you don't remember the deployment name, no problem. kubectl, like how did you get the nodes, pods, all those details? You type the same thing, get deployment. That's it. Get deployments is going to give you, or get deployment it's going to give you, or get deploy. All are alias commands. So it's going to give you the name of your deployment. You know the name of your deployment, then it's going to be easy for you to edit it. kubectl edit deployment. What's the deployment? Or you can type deploy. The name of the deployment, hello. When I do this, what's going to happen is the YAML file which got generated, I can see it in my command line. I can see it in my command line. So the kind of object is a deployment. You will see n number of objects: deployment, stateful set, pod, replica set, lots of things you are going to see. The first kind of object which we are seeing here is deployment. More on deployment as we proceed further. So this is one kind of object. And let me share my own experience here, folks. When I was learning Kubernetes, the word kind was having a different interpretation with me. It was, what kind of object is this? That was the kind word they were using. I was using the normal English stuff. So being very kind to someone, that kind of a stuff. So that was not resonating very well for me. Later, I realized that the way you have to use it is, uh, what is this type? Basically, it's going to be a type of object. So that is what that kind means here, not being so kind to others or to animals. That is not that kind here. So just wanted to, so if you get a confusion like me, just thought of sharing it with you. So it is, this is a kind of object. The kind of object which you are going to use is deployment. So here it's going to be generated for us. These are the entire configuration which got generated by one single line of command, kubectl uh, create deployment, the name of the deployment, and everything which you mentioned is going to be captured. And there are few default stuffs which is going to be there. And the one which you mentioned, what were the things which you mentioned? You wanted only one replica, that is captured here. You want one replica, it is captured. Then you mentioned I wanted a specific image. This was the version, that is captured. Remaining everything is auto generated. Now, one important thing which is important for our auto scaling demo to work properly is the specification for running this image. So that can be mentioned under this resource spec. So under this resource spec, by default, it was like this, empty. I'm just going to remove this. And this is a YAML file. So there's a little trick which you have to play around. Usually three letters space is what you have to give. RES. So this is how I learned it, folks. So if you are going to give a specification for under resources, you give space and never ever use tab. Never ever use tab in a YAML configuration. Always use your space bar. So I can mention, I can request, this is my request under resource specification, how much I can request. So I can request for CPU something like 200 millicores. So this is usually they mention it in millicores, which is nothing but 0.2 vCPU. So this is what you usually mention. So usually they mention it in vCPU millicores, M for milli, meaning minimum I have to have 200 millicores for my image to work, is what I'm saying. Similarly, for memory, you can also mention how much memory you want. And what is the maximum limit you are going to use? That is going to be mentioned by limits specification, where you are going to mention, I want, you can go up to 400 millicores per pod. You can go up to 400. So this is just to keep a limit. I don't completely utilize my node resources. So when I'm deploying this in the node, each pod is going to take maximum 400 millicores or 0.4 vCPU, not beyond that. So this is a very important stuff where you put a constraint of how much resource a pod can take. This is an important concept, folks. Was an interview question for me actually. So which is very important, and this is going to help you to work with auto scaling, because you know per pod it can take maximum 400 millicores. So when it reaches that limit, I have to scale up new. So that's going to help you out. And this configuration was missing when we deploy something in our UI. How do I say that? If you just go for a minute, okay, let me just save it. Let me just save this and quit. The moment I save and quit, what's going to happen is the deployment is edited, meaning it's going to be reflecting. It's going to reflect. Now, why I say when you do something in the UI, it's not going to reflect. The reason is, let me just show you one more time that. Click on deploy. Let's use the same image which we had, 2.0, so 2.1. So if I click on done, continue, give a name like demo. If you see this YAML file which gets generated when you do it in the UI, right? You see this, you get a deployment object. The replica is 3 by default. Your image details are going to be captured. That's it. Those are the only specifications. It does not capture that resource specification. How much is your requested CPU and memory? How much is the limit? That is not there. So this is the reason why when we did it in our last week class, the auto scaling did not even work. Okay, that was the main reason why I added this line about the various resource usage. So Vijay, 400 millicores means how many VCP? 0.4. So so 0.4. That's it. 0.4. It's not even one core, one vCPU. So it is 0.4 basically, Vijay. So you are giving very small resources for running your pods basically. Can we add resource selection from the UI YAML to deploy? I don't know. From the command UI, you usually don't do it. So UI was only to make you comfortable, folks. You have come to a new place. I wanted to make you comfortable. So UI, you may not have lots of options there. So the options which you are going to get mostly in is command line. Go ahead.
so, so Mahesh, from UI, I'm saying we are seeing the YAML file, right? From the UI, can I edit the YAML and add the resources section?
That is fine. That is fine. That
Okay,
is fine.
okay,
That you
okay.
can do it.
Fine.
That you can do
Yeah,
it.
thank you,
Yeah,
sir. Thank you, Mahesh.
yeah, yeah. So now, as Anil asked, if you were to do it in the UI, just click on this edit the YAML, and editing in the console, in the user interface is little tricky, is what I have seen. But what we have added has come up. Now you don't want to give too much, you want to give little less, you do it. You do this and save it. You can do it here also, but make sure that indentation is proper. The only trick which I know is basically, folks, whenever you add anything, the next specification for that should come after 3 letters. RES, the 3 letter. Below that 3 letter, you do it. I'm not a great person with the YAML stuff, but what I have seen as a pattern is this 3 letter space, and never use tab. So that's the stuff. Now we have our deployment. Okay, that's what I understood. I don't know whether any documentation exists, but I learned it in a hard way that you have to always have 3 letter space and then do it. So it's going to become much easier when we go much advanced in the class. So it's going to be easier. So what we have done basically is
Mesh, it
we
is
created.
upper limit or lower limit? Because 300 and you mentioned 300 and 200.
Okay, what? Okay, up minimum is 200, maximum is 300. So if I see the limit request, how much you can request, basically if I just do kubectl get deployment hello, I can use this command to see the YAML file in my command line also. So when I do this, the stuff which you have mentioned is you request for 200, and how much you can request maximum is 400. Limit is the upper limit. Limit is the
Okay.
upper stuff which you can do.
Okay.
And to see the same thing in the UI command line, if you want to do it, you have this command. And there is an official cheat sheet in Kubernetes page itself where all these commands which I'm trying to show you is there already. So it's an official page there, you can use it. Now we have our deployment. We have also edited our deployment. That's good. Now the last part is you need to expose it. Expose it with a load balancer so that you are going to have an endpoint, and you are going to use that endpoint and see whether the output welcome to containerization is there or not. So that's what we are going to do basically. That's what we are going to do now. Before we create the service, it's almost 1 hour 15 minutes. So what we'll do is we'll take a 10 minutes break. Once we come back, we will create a service in the command line, expose it to the outside world. So by creating a service, and we'll see how we can access it. Okay, so take a break. Let me stop the recording. So take a break, Anil. I'll come and comment on that part.
This conference will now be recorded.
So before the break, we saw how to create a Kubernetes cluster from the command line, how to deploy a, how to have a deployment with a specific image. Then we also edited our deployment for some memory specific, CPU specifications. Now we'll expose it as a service so that you people can consume it. Anybody from the internet can consume it. So in our UI, we click on something called as expose. If you remember, if I just go to my console, if you have a deployment and if it's not exposed, it's going to show expose this to the outside world, where you go and expose it and use a load balancer, right? The same thing is what we are going to do it in the command line. So in the command line, so you get two flavors for doing it. Different versions you get from Kubernetes. So it's up to you which one is more comfortable for you. So you can use kubectl create service. Previously we created a deployment. Now we are creating a service, and the type of service you can have load balancer, node port, and cluster IP. Again, more on each of them as we progress. I'll explain you. Then what was the deployment? Mention your port which you want to use for your load balancer and the container port on which it listens. This is one option. Otherwise, you can use a command which resonates very well with your user interface. Expose. kubectl expose the deployment, the name of the service, what type of load balancer you're expecting. Sorry, this single double quote should not be there. The port you want. So two commands are there, whichever suits your style, you can choose it. And I'm going to use kubectl create. The only reason is it's so easy for me to remember it. kubectl create service, kubectl create deployment. So it is on the similar lines. That's the only reason I'm going to use that. I'll expose this as a service, and there's one question which I got from Anil. I'm just going to explain that once I expose it. So currently it is not exposed, meaning if I go to my services, nothing is going to be there. I cannot use this service, the deployment. I cannot consume it from the external world. So to do that, what I have to run is basically a command, which is kubectl create sv. If I got service, then what type of service you want to do? Load balancer is what you wanted to do. Load balancer, the name of the deployment you have to mention, which is hello, and the port which you want to expose. So hello was my deployment name. Then TCP port. So 80 is what I want my load balancer to listen, which forwards the request to port 8080. That's where my container listens on. So this is one way of putting this command. So this is going to create a service. Now you want to see that service when it gets created. How do I see that service? Simple. So if I just put this command, to know nodes, we use get nodes. To know deployment, we type get deployment, get deployments, or get deploy. And to know the pods, we use pods. If you want to know the service, you type the same thing, services. It's going to show you the services. Or you type service, it's going to show. Or you want to type a alias, which is short form svc. All are going to give it. And this is the default service which is going to be there when you create a cluster. So this is for internal purpose. We are going to create our own service, which is a load balancer. So you should see a new entry once we run that command. So I'll put a watch command so that we know what's going to happen. You are going to see a new entry, and the name of that entry should be hello. And the type is going to be load balancer, not cluster IP. What is cluster IP? What is load balancer? More as we progress, I'll explain you. So let me hit enter. Service created. Now you see a new service with the name of the same name which we use for our deployment, hello. Now it has a cluster IP. Cluster IP is a default one. So this is where within your cluster you can communicate with this service. If you were to communicate with that service, you use this IP. And 80, it's going to work. Similarly, port 80, you should be able to see it. And if you want to access it from the outside the cluster, then you have to have an external IP address, which is still not provisioned for us. So it's going to take a couple of minutes. Once it is done, you should have an IP address. If we have an IP address, we should be able to see it, basically. So let's wait for this. Yes, you see an IP address. Now just copy this IP address, which is nothing but our network load balancer. I had shown you this last week. So Control C. What I have observed is if it's in a watch mode, I cannot copy that. So copy this. Just type curl. It shows welcome to containerization. You want to verify it in the UI? Go in the browser. It's going to show you that. That's it. So we have successfully deployed our service in the command line itself. Can we access it through the cluster IP? I missed it. So you can access it through the cluster IP. I'll show you that later. So when I'm explaining what is a cluster IP in detail, you can access, this is your internal IP. You can also access it via this. You don't need to have an external IP. There are certain services which you don't want to expose it. Maybe a middle tier. So assume this is your front end. Definitely you need to have a external IP, but the front end interacting with your middle tier may not need to have an exposure. So at that time, you're going to use this cluster IP for communication. I'll show you that demonstration also. So, but now we wanted to do the same kind of demo which I was showing you, right? Create a cluster, deploy image, we have deployed it, expose the application to the internet as a service. 3 steps we have done it using the command line itself. That's good. So that's where these 3 commands comes handy. Done. Now if I go back to the previous slide, there is an option for us to scale up and down the deployment. Now how do I do that? There are 2 ways of scaling. One is manual scaling. The other one is auto scaling. These commands are important from the exam perspective. Now, if it were to be a manual scaling in the UI, you just go to your deployment, click on actions and change it. Number of replicas. But if you were to do it in the command line, you use kubectl scale. There's a difference here. If it is scale, it is a manual scale. If there's auto scale, it's going to be auto scaling feature which you're going to turn on. First, let me show you the manual scale option. Kubectl scale the deployment. Remember, we had only 1 replica. We wanted to make 2 replicas. Basically, that's what I'm going to do, a manual scale. So let's switch to our console. Now I will run this command. Number of pods, just to show you, it is currently 1. Now what I will do is I will scale it, manually scale it. So kubectl scale my deployment. My name of my deployment is hello. Now how much replicas do you want? Basically replicas. So you can put equal to 2 or space 2, both are going to work. So let's go ahead and try to increase from 1 pod to 2 pods. Hit enter. Done. If I go here to the other tab, it shows it is pending. So first pending, then it goes to container creating status, then it goes to running status. So currently it is pending. Let's wait for a minute or so. Usually it should be quick. If it's taking longer time, you can look into the details why it is not running. Let's wait for at least anyway the seconds are showing for 30 more seconds and see what is the issue there. Could be an issue. So let's verify it. Still pending. And the advantage of that watch command is going to be basically to see running the stuffs. It's not going to create a VM behind the scene. No VMs. So no VMs. So on this one node which you have, it's going to run one more pod basically, Mangesh. So it's not going to create a VM. So on the existing node only, it's going to create it. So 60 seconds over, it is not creating it. If you want to know what is the reason it is not done, you can look into the logs, or you can do kubectl describe pod. You can see some information what is happening. You can see some info. describe the pod. Looks very verbose. Or let me describe the deployment. Describe the deployment, which is hello. Okay. Available, progressing. I'm not able to see it. Okay, I'm not able to see it. So I'm just going to take a small help from the UI to see what's happening. So if I come to deployment, I see some status is not, which is green. So if I just click on this, it's going to show me a message, insufficient CPU. So already we have only one node. It's a one node Kubernetes cluster. You have a pod already running. Now you are trying to run one more pod because it's a G1 small machine. It has no enough resource already. It's already exhausted. It's already exhausted with the resources. It don't have anything else. It indicates I cannot run a second pod. Insufficient CPU is what it gets. I was not able to get this information when I described it in the command line. I'll check it out. But the indication why my pod is not getting created is you don't have enough CPU, folks. Now you connect what you did. You just mentioned you want 200 millicores, 200 millicores, and 400 is the max. So if you want, you can remove resources and do it, Anil B. But we have only one resource which we have provision, nothing else. Only one pod. What else you are going to do and go and remove it? It's not a very powerful cluster where you can go and remove all those things. But it's only one application running, so or a one pod running. So if you delete that also, you can only have one pod. So or reduce your configuration. You can do that. You can reduce it. But I don't want to reduce my CPU limit and the maximum limit there because I wanted to show you auto scaling capability. Now these kinds of issues you'll not get in your new feature called as autopilot. It's not going to happen. It's going to be automatically scaled for you. But if you want to use the standard Kubernetes concept, you will have this kind of issues. So what is the solution for this? I cannot delete my existing pod. I want it. I want two pods to be running now, but I have insufficient CPU. What's your thoughts, folks? And I don't want to reduce my configuration, the limit. It has to be minimum 200. What is your thought to fulfill this requirement? We have to come up. Machine type, you want to change the machine type of the system of your virtual machine. Yeah, so one option which we can do is you just configured basically one node Kubernetes cluster. One way is we can change the machine type. So if I just go to my machine type, it was G1 small. If you can make it little more powerful, that's going to be a possible option. But it's not going to be that easy. Let me just show you. Let's try changing the machine type. First, let me show you the machine type. And how do you change the machine type, folks? What's the steps to change the machine type? Stop. Correct. So we have one node. Let me click on this. The configuration of this one, if I were to show you the machine type, it is G1 small. Now let me try to stop it. I cannot even stop it. So you cannot change your machine type, or you cannot play around like how you played with your individual virtual machine here. The reason is it is not a new virtual machine. It's not an individual virtual machine. It is attached to a instance group. So you don't have much control there. So I cannot stop it. So changing the machine type or playing around with the managed instance group is not at all a good option when it comes to Kubernetes. Why? Kubernetes abstracts all those virtual machine stuffs for you. So whatever you need to do, you have to do it in your uh, Kubernetes screen, not come to virtual machine screen. In very, very simple terms, don't ever come and do anything in your virtual machine screen. So I just showed you only for your understanding. So you cannot do anything. Even if you come also, you cannot do anything. You see, I cannot stop it. I cannot delete it. I cannot do anything. It's only read only stuff is what you can do basically. So changing the machine type is not going to help us, and there are options which I'll show you towards the end, but not in your virtual machine screen. You have to do something in your Kubernetes screen basically, meaning basically you're going to use kubectl containers related commands, or that's what you're going to use basically. You're not going to use something like gcloud compute. That kind of a command you are never going to use. I don't want to create a new cluster. If I create it, maybe I can create a more powerful cluster, then it's okay. But if it's an existing cluster, how do I do is basically, one of you had mentioned, add a more. Why don't you add one more node, folks? Simple. You already have one node, add one more node. That's it. That's going to be easy option, right? That's going to make me fulfill this requirement. So now when we created our Kubernetes cluster from the command line, we did not mention any auto scaling or anything. We did not mention anything of that sort, because of which we have that problem. So if I go to my nodes, you see the default node pool auto scaling is off. At least if it was on, right, when such kind of a request comes, it can scale up one, add more, but we have turned it off. Now the only option which you can do now is click on edit, go to your nodes. Okay, I have to click on here, node pool, edit, change this number of nodes from 1 to 2 or 3, whatever you want to do. Doing it in UI is going to be simple. This is how you do it, but I don't want to do it in UI. I want to do it in the command line. So because this entire demonstration is on command line. So one of the possible option is increasing the number of nodes. Is this clear, folks, till now? So we have an issue. Changing the machine type is not going to work. We saw that. So the only option which we feel is increasing the number of nodes is going to make, node pools in the number of nodes is going to help us. So in the UI, it's easy. Just go to your node pool, increase it. But in the command line, how do we do it is what I wanted to show. And this is an important command. I have seen such questions in the exam. So what we'll do is we are going to increase our new this thing. So this is going to be pending only till you provide some resource. Until then, it's going to be in pending state only. 10 minutes, it's in pending state. Let me add one more tab here, folks. Let me add a tab and run a command which is going to be something called as watch kubectl get nodes to see how many nodes are going to be there. Okay, let this be like this. I'm just going to put this one. Nodes. So I have only one node running, and the version of my node is 1.8, the Kubernetes version. So now what I will do is, now I have to increase the number of nodes. What command should I use, folks? I don't want a complete command. So is this going to be an infrastructure related stuff, or it is going to be something related to Kubernetes stuff? So first of all, is it infra or Kubernetes related stuff? Infra. So if it is infra, then what is the stuff you are going to use? Gcloud or kubectl? Anil B got it. Yes, Anil Kumar also got it. Kumar also got it. It's going to be a gcloud command. So gcloud command, Mangesh also got it. So the command which we are going to use is gcloud containers, container clusters. You are not creating it, you are not updating it, but there's a command called as resize my stuff, and my cluster name is -CLI. That's my cluster name. What I'm going to do is, specifically I wanted to resize my specific node. So I can type a very long command. So if I type a very long command, it goes to second line. I'm also not interested in typing it in second line. There's a trick which you can use. You can put this slash. When you put slash, you can start typing the next command very nicely. So I want my number of nodes. First, instead of mentioning the number of nodes, for which node pool you have to mention it. Since we have only one node pool, it's okay, but it's always good practice to mention what node pool. What's my node pool name? It is going to be by default always default hyphen pool. That's the default node pool which you are going to have. If you want to know it, you can just go to you see your cluster has one or more unschedulable pods. So because you have, and the solution for that, they are saying auto scaling documentation. You see those very intuitive way of teaching from Google. I would say that's really good. So this is my node pool. Currently it is of one size. So what I'm going to do is, so as I mentioned, you can put equal to, or you don't want to put equal to, it's okay. Default hyphen pool. This is my default pool, and put a space. Don't type / here itself. Put a space and add it. Next, it's going to prompt again. Now what Anil B mentioned, number of nodes. What you want, I cannot provide 3 right now. I'll do just 2. So 2 should help me out to figure out this part. So again, I have to mention few other stuffs, zone, but if I don't mention, it's going to take the zone which I have mentioned. But if you want to mention it, mention it. I'm not sure whether the session has gone or not, so I'm just going to type it. So you don't need this if the zone is already set. And I'm going to run it in a quiet mode so that it's going to, thank you, typo. Thank you, Anil. So that's it. So gcloud container cluster resize for which node pool? Default node pool. If you don't mention it, it's going to use this as a default one. But I wanted to make it very clear. You need to mention it so that you know which node pool you are resizing. From 1, I want to go to 2 basically, and zone is not important if it is already set in your session. If it's not set, it's going to take it basically. Now when I hit enter, what's going to happen basically is I should have a new node. So I should have a new node, and when it starts, right, the status will not be ready. It is going to be status like not ready. Slowly it's going to become ready. The moment it becomes ready, the unschedulable pod will become scheduled and it's going to get deployed. This is what is going to happen, folks, in the next few minutes. So hit enter, and if I can, I don't know how can I go to the home screen. Okay, hit enter. It is resizing. So when it clicks, when we see that resizing, right, let's go here. Let's watch whether the new node comes up. So the new node should come up. So once the node comes, definitely we should have that unschedulable pod getting scheduled because it has now more resource. Now we are doing everything manually, folks, now. So I'll show you how we can make this entire process automated in next few minutes. So first, seeing it from the manual way option. So -q is for running it quietly. So sometimes it will ask me for a prompt. Do you want to really resize it or not? I don't want such prompts. Just silently do it or quietly do it. No prompts. Awesome. We got it. We have got it. So you see this is a new pod, folks. Now it is ready. Now once it is ready, meaning if I just go to my this previous command, you see the old one which was not getting created, it is terminated. It just discards it, creates a new one. So and resizing is happening and all those things. So it's going to get created. My two pods should start working basically. So two pods started working easily. So all because of resize. So it was an infrastructure stuff. The resize has happened and you see the pods running. Now if I go to my console, I should not have that error message. I have two pods running. Is this part clear? So now you see the importance of having good number of nodes and the parts with a specific resource configuration so that you decide how much you want. So but entire stuff which we did was basically manual. I manually scaled it. I had an issue, then I had to manually scale my nodes, then only I was able to fulfill it. But is there any better way? Is there any better way? Yes, there is a better way. So the option which we are going to use basically is uh, which we are going to use is auto scale. So you do auto scale deployment, meaning I don't want this manually based on the load which I'm going to put. I don't want to manually go and do kubectl scale deployment. It should be automatic. And I'll also mention how many replicas I want. Minimum I want one, maximum I can go up to 6. So whenever it is hitting CPU of 80, create 1 plus 1 plus 1 plus 1 till what? Plus till 6. So because more pods means what you expect, more nodes you need. So before you do auto scaling at a pod level, at a workload level, you make sure you turn on auto scaling at your infrastructure level. You need to do that also because currently it is not auto scale. So I have just manually increased the node to basically to 2. Tomorrow we are very sure if I make it 6 or something, I will really fall short of my this thing resource. So you should make sure your infrastructure is scalable. So going back to this one, currently what we tried to do was add more nodes. We did not scale, so we had to increase our infrastructure and do it. Now first what I'm going to do is I'm going to make this auto scaler configuration done. Then I'm going to turn on my HPA. So always first is your infra, one then is your workload. So what I will do now is before I do auto scaling deployment, what I will do is I'll make sure my infrastructure can scale, auto scale. So for that, if I go to my Kubernetes page, look at my node pool. Currently my node pool is not auto scale. It is only 2. Now what I'm going to do is I'm going to do a small configuration change where I'm going to mention I can go up to 3 nodes. 3 nodes maximum. If there's a huge load, it can scale up to automatically 3 nodes. So how do I do this? This is again an infrastructure requirement. So by this time you should have a very clear understanding. Gcloud command. So let me turn on the auto scaling. So if I were to do it in UI, it's very simple. Just click on edit, go to your nodes, node pool, click on edit, just click on turn on auto scaling. That's it. So I can have something like this, or I can have something like this, minimum 1. This is what you do it in UI. UI is easy, but we don't want to do in UI. So I'm just going back. What I will do is I'll do it in my command line. So because it's an infrastructure stuff, one more time a command which we are going to run is basically a gcloud command, the same style, gcloud containers clusters. Now this time it's updating the cluster. So I'm not the person who wrote this command. So but I wanted to show you a story and then make sure the command gets registered very well. So we are just updating our cluster. So it's not resize or anything, not create, but it's going to be an update of the cluster. So type update. My cluster name is dev shell -CLI, and because it's going to be again a long command, so I'm going to use this trick space slash. What is a node pool for which you want to turn on auto scaling? Node pool, I can mention equal to default pool slash mention zone or not zone, it's okay. Now the flag which I have to do is enable auto scaling, and this command is important, folks, and that's the reason I'm having a story and telling you this part. So enable auto scaling for this node pool which is in this Kubernetes cluster, and whenever you mention auto scaling, you have to mention the minimum node. Minimum nodes is 1, maximum node which I can afford with my budget is 3. You can also mention it like this. It is also a possible option. So that's it. Now if you want to mention the zone, mention it so that we don't get any error, or it should work. Let me give it. Okay, anyway, I have typed this. I have to type. So Asia. If you want to type -q, type it. If there's no prompt, this command is not going to be of use. But if there's any prompt, this -q is going to be silently running it. So this is the command, folks. Gcloud container cluster update, and I've seen this command asked in the exam. So to do an auto scaling, enable auto scaling for this node pool. The minimum is 1, maximum is 3, and this cluster is in this zone. Do this quietly. That's it. Hit enter. Let's see what happens. The cluster should be now configured with auto scaling capability. So if you want to see the status, for a short time the connection got refused. Why, folks? Why the connection got refused? Any thoughts here? I'm not able to connect it. Let me just show you. I'm not able to connect. Changing the infrastructure, meaning upgrading your master. Updating your master is getting upgraded. So definitely you will have a downtime. You see, upgrading the cluster, the value shown will be updated soon, meaning you are having a zonal Kubernetes cluster, only one master is going down for an upgrade, so you will have downtime. So your kubectl commands will not work, but your website is going to continue working, if I'm not wrong. You can give a try. The link which I had mentioned, your website is going to work continually. So but if you want to run any kubectl commands, it's not going to work for a short time because the master is getting upgraded. So you get the value of going with a regional Kubernetes cluster. So at that time, if you were to do run some kubectl commands, it's going to be helpful. Otherwise, you have to wait till the master comes up. Okay, so this is where the zone regional Kubernetes cluster comes handy. So it's going to take time for it to come up, upgrading it. And if I just go to the UI, you should see the master is getting upgraded. So to have this kind of a configuration, the master also needs some better capability. So that's the reason it's going for an upgrade. So we have to wait to come. Once it comes up, our stuff should start. Let's see whether it is running. So I would say that doing this kind of demo is going to help you understand your concept very well. It's going to take time, but your concept will become very, very clear. And commands like this watch, all those things is going to be really handy. So Google designed it very well, and okay, Thank you. So let's wait for this to come up. Let's wait. Once it comes up, right, what we are going to do is we are going to do this auto scaling part. We are going to do this. And that's the cool part of the demo, which I would say. And we are going to do some loading. We will put a huge load on the system also. Not using Apache benchmarking tool, but using a different tool, because we know already how Apache benchmarking tool works. We'll try to use some other tool called CH. That's another nice load testing tool. We'll explore that. Having more exposure on different tools is going to be always helpful. So when we put load, we will see it will start from minimum 2 pods. It can go up to some pods, and we'll also see a new node getting created. All those things is what we are going to see. Once we do this auto scaling part, we will go back to our deploying a newer version. So let's wait for our pod to come up. It's taking time. So by the time this comes up, so cannot connect is what it shows usually. So it's not able to connect it because the master is down. But if you had a regional one, you would not have faced this problem. We have to wait. This is a slightly longer process. But is the application down, folks? Do you see anything? Do you see anything downtime there? Is your application, the application link working for you? No, right? That's it. That's okay. That's okay. That's okay. That is what we expect. Yes. So infrastructure is getting upgraded, but so because it was a zonal one, we are not able to interact. So I need one more tab. Hope it gets provisioned. You showed us all through the communication. Yes, the kubectl always interacts with your master. The kubectl always interacts with your master. So it's all sent to the master. The master then sends the traffic stuffs to your this thing. So by the time this comes up, there was okay up. It is up. So my this thing is updated. Now if I connect it, I should see the stuffs. My master, everything is up. So I'm in a good position now. I should go and start doing the auto scaling part. Now, before I do auto scaling, right, I'm going to manually scale it down to 1, folks, for a specific reason. So why I'll tell you that. So how many nodes are there? 2 nodes are there. 2 pods are there. Okay, 2 pods are there. Now I will scale it down. So kubectl, we know the command kubectl scale deployment. The name of the deployment is this thing, replica equal to replicas 1. Done. Now if I do this, 1 would be terminating. So let it go. Let it go. There is a specific reason why I wanted to do this. So let it get terminated. So it's going to get terminated in the next few minutes. Now I don't want this all trouble making stuff. Scale it manually, scale it down, add more resources, all those things. So now from the infra part, I have made sure it can scale up to 3 worker nodes. That's good. Now from my workload part, I can go up to 6 is what I'm giving. This is a number which I'm just giving. So I'm going to configure this auto scaling, horizontal pod auto scaling with this command. Kubectl auto scale deployment minimum is this, maximum number of replicas is this. This is not nodes, this is replicas. And I'm mentioning a metrics 80%. Let's see what's going to happen. So what I will do now is I will do kubectl auto scale. Type auto and hit tab. It's going to auto complete. Auto scale your deployment. Name of my deployment is hello. Then the minimum which I want is 1 replica. Maximum which I want is 6 replica. The CPU utilization, CPU percentage is 80. This is what we mentioned. The same thing is what we are using. So when I do this, it's going to have a HPA created. Now, if you ask, is it still not having an HPA? No. If you do everything with the way which we have done so far, there's no HPA. How do I verify it? Whether HPA is there? Simple. kubectl get HPA. Nothing is there. But the moment I do this, it's going to apply horizontal pod scaling to this namespace. Done. Now, if I go and run this command, it's going to show HPA is turned on. Now, last time you were seeing this target was unknown because we did not have that limits. This time we have kept a limit there basically. So what you can do is if you run this command one more time, you should see that 0%. So this was not happening last time. Kumar also had asked this, can we show auto scaling demo? So it was not having that specification. CPU under the limits, what is the maximum limit you can have the request, all those things. That specification was missing, and because of which it was always showing unknown, but now it shows 0. Now the most important thing is if I put this in watch mode, minimum is going to be 1. Currently the replica is 1. Minimum you can have 1, maximum you can go up to 6 is what it indicates. Okay, and currently it is 67 seconds. Now if I put a load, it can go up to 6 pods, and if it needs more infra, I can come to basically one more node. I can have 3 more node, one more node extra. Already 2 nodes are there. It can scale my node to one more basically. Let me just show you that part also. So 2 nodes are there. We can have one more node if possible because we have configured it. Now it's time for us to put a load, folks. Till here, is it clear? Till here, is it clear, folks? Till here, is it clear? Okay. So if it's clear, what we will do now is I'm going to put a load using a tool called as CH. So this is another nice tool which you can use. And if I type it, I may not have this command by default. So I have to do a install ch. And we know Cloud Shell is ephemeral. So if you tomorrow come and see, this utility is not going to be there. If you want to keep this utility, what I would suggest is type which. This is the location. Copy this file to your home directory. Then it's going to be retained. So if you want, you can keep it. I don't want to keep it. I'm just going to use this. So ch minus c, how many concurrent requests you want to send? So 250, I'll mention it. To which load balancer or to which IP address? This is the stuff. So if I just send, so 50 concurrent requests is going to be sent continuously. So you will see auto scaling increased basically. I'm going to, I just need one more tab, folks. I'm not getting this tab. Okay, good. I was very desperate for this tab because I need 2 or 3 commands to run. So we have one tab where it shows my HPA configuration. This is currently the number of replicas. Watch for this column when we do auto scaling, and it can go up to 6. And one more stuff which I wanted to show you is put watch command and kubectl get nodes. I wanted to show you this also. So maximum one more should come. Okay, now let me put load, folks, and let's watch this number. So you should see auto scaling in action. I'm just going to highlight this number. Replicas, just watch for that. So it's now auto scaling in action. Let's wait for it. And first you should see the percentage. It's going to exceed more than 80. Then you will see more replicas added. So let's wait for this. and it's going to auto refresh every 2 seconds. So we don't need to do anything. Sit back and watch. That's it. And I'm not doing anything. I'm just watching it. Also, first the target percentage should increase basically. Let me see, is there any error here? No, it is going on. Good. You see that 200%, the target has hit 200%. So it's going way beyond this thing. So this replica should definitely become high. It should definitely become high. Let's wait. 3 replicas. You see this, folks? 3 replicas. The moment it became 3, the target reduced, because now 3 replicas is able to handle the load. So that's good. Now if I go to my nodes, there's no additional nodes added. So with the two nodes itself, 3 replicas are working fine. 3 nodes are running, sorry, 3 pods are running in 2 nodes, and we are continuously putting load. This is continuously under load. This should again, now you see 6 replicas. You are going at 136%. 6 replicas. Now let's see whether it requires a new node. New node. Let me see whether it is new node is required. Let me just see it here. I'm falling short of tabs. Definitely, you see this, folks. Insufficient this thing. No problem. Don't worry. We are going to get it because auto scaling is already there. So you should see a new node getting provision now. So because we have already hit 6, and to provision those, you see this, a new node got created. Previously we had only 2 nodes. Now because of auto scaling at the node level, to achieve that 6, we are able to provision automatically a new node. Now if I refresh this, does it go off? It does not go off. It does not go off. It's creating. Okay, it's creating. Let's wait. All there. All there. So we were successfully able to see pod level auto scaling and node level auto scaling. Now you see the last time it was scaled was around 1 minute or 2 minutes. So in the next 5 minutes, the replicas will slowly scale down. If you don't put further load, let me just try loading. Stopped. Now if I don't put any further load, slowly after 5 minutes, maybe at 12th minute, you should see the number of replicas coming to minimum 1. Once it happens, in the next 10 minutes, one node will get automatically shut down. No load. After some more time, second node will go down. So it's going to be remaining with 1 node, 1 pod. So it will create up to 3 nodes. Yes, Mangesh, because we have mentioned up to 3. That's it. So if you put still further, it's not going to happen. So is this part of the demo clear, folks? We saw auto scaling, pod level and node level both.
And if
And
3
both
nodes
goes
are
in
also done,
conjunction.
what will happen?
Sorry?
If we go, I
If
mean,
all
if it goes beyond 3 nodes, what will happen?
So you'll get
The
that
app
error
will-
message, insufficient,
Okay.
insufficient CPU, I cannot deploy. That's what it's going to complain.
Okay.
So you have to add more nodes then. More nodes has to be added. Now, zero traffic. You are not putting any much load there. So because we have cut it. So to show in next, I guess at 12th minute, it's going to become, because the documentation says it takes 5 minutes to have a cooldown. So if there's no traffic, it's going to become 1. And again, the documentation said if there's no traffic or anything, for after 10th minute, it's going to become basically 1. Highlight which you can see here is the age of the node is going to help you out which one was recently created. So this was the one which was recently created when auto scaling node level auto scaling happened. The first node which was created was this one. almost 80 minutes before we start, when we started our entire demos. This is the oldest node. After that, we did gcloud resize command, right? Then it created this one. Now, when we did auto scaling 3 minutes back, it got created. So when it comes to 10th minute, right? If there is no load, this node will automatically get deleted. 10th minute or 12th minute, roughly 10 after 10 minutes is going to get deleted. So let's just keep an eye on this. So in next 3 minutes or so, it should get removed, folks. So let's wait. I just wanted to show you this part. Let's wait for this number to go 13th minute, because at 7th minute, everything scaled down. We did not put load. Afterwards, next 5 minutes, it will see no load. It's going to scale it down to 1, the number of replicas. So you wanted to see the number of replicas. I'll put this command, watch gcloud, kubectl pod. So all are running. 6 pods are running now, and 6 pods are running. If you see the age also, 5 minutes. It's almost all are 5 minutes old. So should get soon removed if there's no load. We are not putting any load. It's quiet now. It's a quiet period. I just wanted to leave it here just to show you the number of replicas which goes down. First, the replicas will go down. Afterwards, your pod will go, your node will go down. So at the 12th minute, it should happen something. Auto mode I have not explored much, Kumar. So it is just 3 days or 4 days back product. I have not explored it much. But the simple thing is that you don't need to worry about nodes. So you need to only worry about pods. That's an explanation which I understood. So I have not seen it explored, and you will never get that question in the exam because brand new product. So you cannot, and they don't expect you to know that. For some reason, it's not updating this age. Okay, let's wait for this. So let me just Control C, do it one more time. So should get deleted, folks. It should get terminated soon. I wanted to show you this. We have come till here, so waiting for a couple of, you see this, folks, terminating. You see it is terminating. So it will slowly scale down. So let's just wait here to see for it. So one is getting terminated. Similarly, you will have other parts getting terminated because 5 minutes I waited, nothing is there, and I'm just going to scale down. So let's wait for this. 4, 5, it became 5. Now, if you wait few more minutes, it's going to keep on doing that, and it's going to make it to basically 1. At the end, if nothing is going to be there, it's going to make it as 1. So just let's wait for a few more minutes. And once it fully scales down, you will not have a node. And the node which is not going to be there is the one which is very short. When this comes to 10 or 11, 10 is the actual documentation, but to do all the check internally, all those things, it takes a minute or so there. So by 12th minute or so, this node also will go down. So you'll be only left with 2 more nodes. And after sometimes, I have not seen how long it takes for the second node to go. If you are interested, you can just leave it and see it, but it takes longer time to scale down the second node. The first node goes down after 10 minutes or so. Let me see what has happened. Awesome, folks. You see 1. So no more terminating. This is your pod auto scaling up and scaling down. You saw 5 minutes is what it takes. Now if we just can wait for 3 more minutes, we should be all good to see this. Maybe what we can do is we can take a 10 minutes break, and I'm just going to leave the screen as is, so that if you are interested, look for this and see where when it scales down. Or if you're okay to wait for 2 more minutes, we can just wait and finish it off. let's just wait. Maybe I would say it's going to be good if we wait for 2 minutes. So where there's a clock ticking and you see that. Any questions by that time, so that instead of having a silence, I can cover it up. There's something which Anil asked about boot2, a dot boot2. This is basically for encryption purpose. So when you want to use basically customer supplied encryption key, all those things, we'll talk about that boot2 file in our storage class, Anil. So that's going to be there by default. So as a hidden file, explore it. We'll explore more on our storage class. I'm going to talk explicitly on that. So we don't have any parts running, only one replica running.
So Mahesh, last time when you showed us the instance groups, right? That time you showed us multiple, for example, Asia region, US region. In the same way, this also applies in the same way, right? I mean, now you've done it
No.
in the region level, zone level.
So that will not apply here. So what you create is a zonal Kubernetes cluster, meaning all these nodes are in one zone. If you make it as a regional one, your worker nodes will be in, it's going to be a regional, maximum regional only. So if you want multi-region, you have to create multiple clusters. So then you have to have a ingress, which we'll talk about again later. So you can have multi-egress Kubernetes cluster. So one Kubernetes cluster, it is going to be either regional or zonal. That region is going to be fixed. So you can have n number of node pools in the same region, but not in a different region. So meaning if you were to replicate the same demo which we saw in our Kubernetes virtual machine, you need to have 3 Kubernetes cluster in 3 different regions.
Okay. So it is, now you showed us only one region, multiple zones.
Yes. Yes.
Okay. Got you. Thank you very much.
So 10 minutes. Yeah, 10 minutes over. So we should see in next few minutes this going as not ready, and it's going to be taken back. I would say it's worth waiting, folks, even though it may look little silly to wait and see, but this concept is going to be really making you very good, saying that, okay, how auto scaling works and when it goes down also. So the documentation says 10 minutes it's going to go down. So 10-12 minutes it should be there. So let's wait for this. It should become unready and then it should be taken back. So maybe if I can just go to my virtual machine, refresh it, you should see 3. You have 3 currently. 1 should go back. So 11 minutes over. Okay. The clock after 10 minutes, it will not show the seconds. Okay. The age. So it will not do that. Okay. Good. Let's wait for this. 11 or 13 minutes. We'll just wait and then we'll. But this is going to work. I have seen this. 12 minutes is what I have waited. So it basically works that. So once this happens, right, what we'll do is we have only one last part pending where we are going to have a new image with 0 downtime. How do we do it? It's going to be basically a feature of Kubernetes itself doing a rolling update. But how do you do it from the command line is what I wanted to show you. So using a command called as kubectl set image, a very important command from the exam perspective. And the same command we are going to use later in our CI/CD process. So 12 minutes over. Hope it comes down.
So Mesh,
12 minutes. Okay.
the command which you use for the ch command, right? So I mean, since it is a regional wise, so it will handle the request from that region only, or it, I mean, if I access the application from outside that region, it will also handle that request.
It will be serving even from the outside region also. The only thing is that you will have a latency. That's it. You will have a latency because now it's done in Singapore, so it's going to be serving the stuffs much faster for Singapore region. But if you access from US Central, you will feel latency. So for that, you have to make sure you use multi. So there's a concept called as, if I search for this, multi-cluster, multi-cluster, multi-ingress Kubernetes. There's a concept like this. So you create multi-cluster ingress, so that you will not have any latency. So you're going to have multiple Kubernetes cluster, and you're going to have an ingress. What is ingress? I'll talk about that later. So with this option, you will be able to achieve for across the globe if you were to do it.
Okay.
So yeah.
Thank you.
So the part on the exam part, I'll just add it. So it's taking minute. Okay. It's taking time. Okay. Let's just leave this. Let me just go and add that exam tip. So this command has to be added in the exam tip. So let's do this last part and then take a break, folks. So change, I'll just add that, Kumar. So I have to copy it from the slide. So I'll do it later. So don't worry, I'll do it later. So the last part is change to a newer version. So like what we did it in our UI, deploy a newer version. Since we already have a new new image, what I'm going to run is this command, kubectl set image, the name of the deployment, and you need to mention the container name also here. What is your container name? And point it to a newer version. So let's try to do this and see what's going to happen. So for this, it's still going on. So maybe I have to wait for some more time. It's okay. So what we'll do now is change it to a newer version. So it should show version 3.0. I can put this in the chat if you were to see when it's going to show up. So I wanted to show this one, pod. Currently this is the pod running. So what I will do is kubectl get deployment hello. I don't remember the container name because the command expects a container name to be provided. So I can get my configuration by doing this command. What is the name of the container which I gave? I should have a name to my container. Okay, the name of my container is my app only. So now from 2.1, what I'm going to do is I'm going to make it as 3.0. So how I can do it? In two different styles I can do it. kubectl edit deployment hello. I can do it in this style. Go simply change it. It's going to change it automatically, auto deploy. Otherwise, I'm not going to do it here. The otherwise it is cancelled. The other style which I can do is kubectl set image, the deployment slash the name of the deployment which you had, and the container name, my app was my container name. And what was the version which you wanted to do? So colon version 3.0. This is what I wanted to do. Basically, it should be the image name, right? Sorry. Thank you. What was the command? No. The image name is not required. So you just mention container name equal to. So this is the container name. My app is the container name. So you are changing the value of that. You are changing the value of it, Anil. So what I wrote was correct. I little got confused. So basically change the image of this deployment and what is the specific container name and what's the version you wanted to set it to, basically. So container name and your URL. When I do this right, what's going to happen is the existing pod is going to get terminated and the new one is going to come up. basically. So let me just do this. Hit, come here. You see it's pending, creating. The old one got terminated and the new one is up. So simple. So simple. Now if I just go refresh it, it should show me the stuff. So what we did in the UI, we saw that even in the command line also. So okay, good. This is something which I wanted to show. You see this, folks? This is not ready. So in next few minutes, this is going to go off. This in the next few minutes is going to go off. It took 18 minutes actually. 10 minutes is what the documentation says, but in 18 minutes, it's taking all the stuffs. In next few minutes, this is going to totally get, it's going to disappear from the screen. This is your node level auto scaling. It can scale up and also scale down. Let's wait for a few more minutes. It has become from ready to not ready state. And what is that node which goes down always first? The one which was created recently. So the one which was there almost for 101 minute, 4 minutes is still there. 41 minutes, it's still there. The one which was recently created, it's going to go off. So let's wait for this to go off. So if next few minutes, it should go off. Meaning if I go to my virtual machine and refresh this, there should be, you see this, folks? The instance is getting stopped. Once it gets fully stopped, you should not have any entry there. Gone. It's gone. So this is your node level scaling stuff. And we have a newer version running. That's it. So is this part clear, folks? I just wanted to show you the complete stuff uh, with scaling up and down both, because I've not seen many courses doing this. So I just wanted to show you this entire stuff, so where you have a better understanding of how auto scaling works. Most of the people show MIG auto scaling. They don't show Kubernetes auto scaling very well. I have seen even in some official courses, I don't see that, but just thought of sharing it with you with this part. So if it's clear, what we'll do is, one part of the demo, we have finished it. Everything using command line. But this is not the best option. The best option is using something called as declarative configuration. We are going to see that part. That's going to be the ultimate one. Going forward, you should always use that. I'll show you that. Again, the same concept using a different approach. So, but before that, let's take a 10 minutes break. Once we come back, uh, we will look into a small question, answer it, then go into that declarative option. Okay, so let me stop my recording.
This conference will now be recorded.
So before the break, we saw how the imperative configuration works, and we did the entire stuff which we did in UI in the command line. So now we will just have a small question, answer it, and then go to the next part, which is the declarative approach. Before that, there's one question from Deepak. When will you be doing networking? Do you have any past videos? Been waiting for a while. So networking is our 5th module, Deepak. So we are in the module 3. So once we finish module 3, 4, networking is going to be coming. So if you are interested in a specific part of the video, let me know. Just drop me a direct message which part. I'll see if I have anything. I'll just cut that and share it with you. That specific concept. What specific concept if you're looking in, or if it's networking in general, let me know. So drop me a direct message. I'll let you know. But we are going to cover it in our module 5th module. So it's going to take some time for us to come to that. We are still in our module 3. So now, hope that answers your question. Now a small question, folks. A small question, because it's been a while we did not discuss any question. So there's a question, and I'm going to give you 3 minutes, slightly a complex question. So I'm going to start my timer, 3 minutes. Check it out, and please change your mode to only me, Mahesh, or to the presenter, so that only I see your response. Let's give everybody a chance to give their response. Thirty seconds over. 1 minute over, folks. No response. Deepak Bhandari got it correctly. And it's slightly difficult question, so that's the reason I gave you 3 minutes. We have done this, folks, today itself. One wrong answer. Kumar got it correctly. Deepak Bhandari and Kumar got it correctly. Anil B got it correctly. Last 30 seconds, folks. 3 minutes is the max which we can give. No worries, Anil B. One wrong answer. Last 15 seconds. All right, time up. So only 3 of you gave it correctly. Deepak Bhandari, Kumar, and Anil B. Let's go to the explanation. So let's make it clear so that it's going to be helpful. So you want to enable your running Kubernetes cluster to scale as demand for your application changes. So basically they are talking about auto scaling. So as it goes, it should be basically you should scale is what they are asking. What should you do? Simple auto scaling question in simple stuff. So add additional node to your Kubernetes cluster engine using the following command. So this is going to resize it. So this is going to have a fixed number 10, which is more traditional. This is manual scaling, as Anil B mentioned. So it's a manual scaling, can definitely fulfill, but it is not on demand. It's fixed. Even if there's no load, 10 virtual machines, 10 worker nodes are going to be there. So it is not an efficient way. So A gets ruled out. Option B, add a tag to the instance in the cluster using the command. So gcloud compute instances. Now, whenever we are talking about Kubernetes, and if there's any command related questions like this, and if it is that to gcloud compute, I'm not going to even look into it because I cannot do anything with gcloud compute because it's abstracted. The virtual machines are abstracted from Kubernetes. So you should never touch the backend system, instance group, all those things. You should never ever touch it. So anything on this, I'm going to totally discard it. And also for your information, such a command does not exist. Okay, even if you don't know it, but the concept is going to help you out, that I'm not going to directly modify any virtual machine stuff using my Kubernetes stuff for my Kubernetes. So B gets ruled out because of that. Update your existing Kubernetes cluster with the following command: gcloud container clusters update, name of the cluster, enable auto scaling, minimum is this, maximum is this, and for which node pool. Zone is not mentioned, assuming the zone is something set in the command. So this command is going to help us, right? If I'm not wrong, this should have supported us to do this auto scaling. So minimum is 1. If it scales up, you're going to have more nodes, maximum 10. And assuming you have turned on HPA, the pods can easily scale up and down. So C is something exactly which we did in our demonstration. And the whole reason for doing this demonstration was to explain this question only. I could have just stated this is the command, but I wanted to have a story there and you understood that story. Is my understanding. So I was expecting everybody to answer it, but only 3 of you answered it. That's fine. So at least now C looks more appealing is what I would say compared to A and B. B totally not possible. A is more manual and it's going to be very cost. It's going to be expensive solution because always 10 nodes are going to be running. So which is not I want because it's on demand. The word on demand is the most important highlight here. The option D, create a new Kubernetes cluster with the following command, where you can create a Kubernetes cluster with a specific node pool turned on for auto scaling. This is also a possible option, but this is on an existing cluster, right? So meaning I have to migrate my load to this one, which is not a good option, right? So D, A, C, all are possible options, but the best one, if I would ask, in the same existing cluster, I have to do means C is going to be a good choice. So D is going to be possible, but you have to move your workload from that cluster to this cluster. So you have to have that. So okay. So answer is C. Okay. So answer is C. Hope the explanation is clear, folks. And we did this demo. We know this command exists. We know this command exists. So that's the stuff which I wanted to share. Now, the most interesting and the best way to work in Kubernetes is using something called as declarative configurations. So what do you mean by declarative configurations? You are going to mention everything. Say this is my desired state, get me that, that's it. So you're not going to send any commands where kubectl create service, create deployment, because those commands you can lose easily. But when it comes to declarative configuration, everything is in a YAML format. You can keep this YAML files in a source repository like GitHub, Bitbucket. Google also has its own repository so that all the changes are tracked. And if you were to change it, you can just have an updated version and you can update it. And it's going to be, everything is declarative. I want 3 replicas, get me that. I don't know how you are going to do it, but get me that. So that's going to be the declarative approach, and this is the best way to work in Kubernetes. Now, how do I do it? No worries, Vivek. So if you have understood that it is C is the answer, no problem. So you got confused with Mangesh and Mahesh, so no problem. So uh, this is the approach which we are going to take, the best way. Now I could have directly come to this. You can use different approaches based on a scenario. For example, if you are learning, use GUI to some extent. Now, if you have become an expert in Kubernetes, imperative configuration is going to be something quick, you can do it. But if you want to track everything, keep a track of what's going to happen, what's the change which you're doing, declarative approach is always the configuration is the best approach. And the command is only one command which you need to remember. Simple. Kubectl apply -f. -f is a file, and you are going to mention whether it's a deployment file or a service file. That's it. So let's try to do this. So now what I will do is I'll keep the same cluster, folks. So this is also command line only, but the way you're going to deploy your workload, all those things is going to be slightly different. So what I will do is I'll only remove my workload, my service, all those things, but I'll keep the cluster because I don't want to waste 3 more minutes for creating a cluster. So what I will do now is there are workloads running. So how do I delete my workloads? Basically, you see 2 nodes are still running. So it's going to take a longer time for the node to get deleted. So first, what I will do is I'll remove my service. kubectl get svc. So there is one service which is running. I don't know why the form is. Okay. This is going to be good. So I'll just remove the service. How do I remove it? Now, by this time, you should have got a small hint how to remove it. Any thoughts, folks? How do you want to try removing this? Remove this service. Any thoughts? Just a guess. It's going to be kubectl. Everybody knows. It's going to be kubectl. Delete. That's it. Stop will not work. That was a good thing. So there's no stop and start here. Delete. So delete. What is that? Delete svc. And what is the name of the service? Done. delete. So the commands are very, very easy. And please remember all the kubectl commands which you are learning in this class, you can apply it even in your AWS Azure cloud. This is a standard command which you use. Only to provision your cluster, the gcloud command is specific to GCP. In AWS, you may have something different. In Azure, you'll have something different, or you can do it in their console, the web console or the web portal there. But kubectl command is going to be the same thing. Even if you're running something called as a mini cube, Vivek was talking about mini cube, he wants to try. So you can use the same command there. All the kubectl command works in every Kubernetes version, which you are going to run in with different cloud platforms. Done. So the service is removed. So what we'll do is we'll remove our deployment also. Get deploy. So there's only one deployment. So let me just go and remove this or delete it. Sorry. Delete deploy. I can type deploy, deployments. Anything is going to work because these are all alias. So let me try deployments. Hello. Done. So now if I do get pod, it's going to be it's terminating. It's next few minutes. It's going to be removed, and we should have a empty cluster. We should have an empty cluster. So let's just wait for that. By the time that comes, as I mentioned, you should use basically some repo to keep all the configurations going forward, because these commands which we did, the imperative configurations, it was all commands. How do I keep those commands in a repository, folks? I can just copy it and keep it, but versioning of those stuffs is not going to work. But what we are going to do is a declarative approach where you will have a configuration created and you can keep that in a version control system. In GCP, you have a version control system called as cloud source repository, like your private Git. It's going to be like how for Docker Hub, you had an equivalent in GCP, container registry, which was all private. Similarly to your GitHub, Bitbucket, GitLab, you have a private Git in GCP called as cloud source repository. So it's better we keep all our configurations here. So under tools, you should see source repository. Let's just create a repo and we'll call it as Kubernetes configurations, something like that. Currently, I don't have any repository. I'm just going to create a repository. Create it. Have this name as GKE configs, GKE configurations. Configurations, which project? Batch 6, create. I've created a repository, a source repository, where I can keep all my configurations. So it's going to be tracked, versioned, all those things. And this declarative approach and configuration option goes hand in hand. Usually when you create a repository, you can clone it and you can update all those things. You can do it. So let me clone it. There are different ways of cloning it using SSH authentication, which is going to be a little tricky for me to do it. I'll go take the easiest option, gcloud SDK option, where I just do gcloud init, which I have already done in my cloud shell, and I'm just going to clone it. So let me just clone it. So I don't have anything here. Let me just clone this. We'll talk more about cloud source repository in our CI/CD process, but here, since we are going to talk about keeping our versions there, I thought let me use this repo, cloud source repository. So this is my stuff. Now you add any files here, we can commit it, keep a track. What was the last change which you did to your Kubernetes cluster? It's going to be versioned. All those things are going to be there. So we have a repo, and this is going to be an empty repo. Empty repo. You need to populate the content. So how do I populate the content? You have to write some code. And the moment I say code, don't get worried. There are some good tools which you get. I will definitely say you'll become a fan of this. In the next few minutes, I'll show you that part. So before that, the cluster is empty, folks. It's an empty cluster. nothing is there, just an empty cluster, no services, no workload. Back to square one. All right. Till here, is it clear, folks? We have not started declarative approach, but we have just created a repository where we can keep those configurations, and we have deleted all our stuffs. All our stuffs. Any questions till now, folks? All right. I'll take silence for my advantage. No questions. If there's anything, please let me know, folks. It was just a fun thing saying that I'll take it to my advantage. But if you have any questions, please let me know. Now, what we are going to do is this demo, I would strongly suggest you to do it only in Cloud Shell, nowhere else. Most of them we are doing it in Cloud Shell, but this one must is what I would say. The reason why I would say it has to be must is there is a editor which you get, which is the coolest editor which I have seen so far, folks. Even though it may have some glitches, I really like this editor. So to open the editor, you can just click on this. This is terminal. If you click on open editor, it's going to open up your editor. So here, what I'm going to do is I'll go to this folder, which is where I have cloned my repo. Inside this, there's nothing, empty. So what I will do is I'll click on file, new. I'll call this file name called as deployment. You can call it anything, any name, sample1, sample2, but the extension is very important. Deployment.yaml. It has to be .yaml only. Is this part clear, folks? It has to be .yaml. The name could be anything, whatever you want. Mahesh, GCP, whatever, GCP.yaml, GKE.yaml, anything. But it has to be the extension should be .yaml. Okay, so let's just type okay. That's it. Where do you get the code? You don't need to worry. You don't need to copy paste from some source or from my cheat sheet or anything. Just do control space. If you use your control space in your keyboard, the code is going to get generated for you. That's the beauty of this option. So if I just remove this, just do control space, you get lots of pre-built configurations. So the one which we are going to look is Kubernetes deployment. Kubernetes deployment. Click on Kubernetes deployment. You get a complete YAML auto-generated for you. Let me just give, and there is a blink happening. If you just give that name, everything is going to apply to there, is what it indicates. Basically, you just give a name to your deployment, then you will have a label and your container name. Everything is going to get automatically created. So let me just give it as hello deployment. That's it. Save. I'm done. I'm done with my kind of object which I wanted to have is deployment. I have it. Now, what else needs to be given? Basically, you need to give your image. What is your image? By default, it's going to give some image which is called as busy box. We wanted to use our image. So I'm going to go to my GCR, copy this, go back, remove this entry, add this version to version 2.1. Done. And it also adds those resource specifications we added manually, right? Here it is added automatically. It's just giving you an idea. So CPU minimum is 100 millicores. Maximum you can go up to 500 cores. If you don't want 500, keep it 400. That's okay. Memory wise, megabytes. So 32 megabytes, and it can go up to 128 megabytes. Now you can see that resource constraint which you can put very easily. This could also be an important stuff, folks, from the exam perspective. So let me just copy this. I'm not going to be able to, yeah. I'll just copy this and go to my exam topics cheat sheet. I'll add that kubectl set image. I'll add it later. I have to copy it from the slide. So resource specification. Sure, I'll show that. Resource specification in deployment YAML file. It's very important. So this is very important. You can give whatever you want. It's going to be usually in millicores and this thing. Now, as per Mangesh's requirement, he wanted to know how we this YAML file. Let me just delete this. So if I just go to a folder which we have just cloned from our repo, I'm going to click on new. Give a name. Any name is fine, but .yaml is important. .yaml. So once you do that, do control space. You'll get lots of options, lots of configuration options, pre-built. The one which I'm going to choose is deployment. If I do that, it's going to show me all my configurations for having a kind of object which is deployment. So just give a name to your deployment. Hello-deployment. That's it. Now give your image which you wanted to use, because they give a pre-built image which is BusyBox, a lightweight testing option. We don't want this, so I wanted this. This is the coolest tool which you can use, folks. I'm sure there are a few, but I have not explored it. But this I felt was really helpful. So that's it. So you have mentioned a kind of deployment. Then what is the image you want to serve? Plus your resource utilization is also mentioned. That's really good. And the container on which it's going to, the port of your container, 8080. That's where you are going to listen. So that's going to be mentioned there. Now everything is good. The only thing which is missing here is the number of replicas. How many replicas you wanted to give. That is not mentioned in this template. That's not mentioned in this template. By default, the replica is 1. If you want to explicitly mention the replica, you have to go and add that replicas word and do it. Now I don't know where to add it. Now this is where the tool comes very handy. If I think I have to add it somewhere here, please use spacebar, folks. Please use spacebar. And if I do replica 1, what's going to happen is there's a validation which is going to happen in the tool. It's going to show me you cannot put this in this specification. It has to be not at a container level, but it has to be at a deployment level. So it gives me that validation check. So I don't need to go and run and get an error. So if I just do, okay, it's not doing undo. So I cannot put it in wherever the place I want. So there are some specifications you have to put it there only. Here, if I put, it's not going to work. Now, where should I put it? You need to look into the documentation for that. It has to be part of your, it should be 1 minute. It should be part of your specification here, not the container specification, but it should be at a deployment specification. So if I just hit here, space, 3 letters again. Now, when I just do this, do space, right? It is already giving me these options. These are the options which you can have. What I want is replica, auto suggestion. By default, it's 1. You just mentioned that. That's it. So simple, right? Any questions on this, folks? So we did not have a replica, so we just wanted to add it. And in which place to add, it's going to give you that very nice validation. Very handy tool when you want to use this. So is this part clear, folks? We have replica, 1 replica, we have the right image and with the right configuration. Any questions on this, folks? So it took time to build it, but we did not type anything. We just use all the auto suggestion options which we had.
So we
Leveraging
cannot
a
add
tool,
anywhere,
basically.
right? It has to be
Sorry?
particular place. We cannot add these replicas DAX anywhere, right? It should be at a particular
Yeah,
place.
it should be in the specification only. It should be in that. Otherwise, it's going to throw you an error. So
Okay.
it has to be under your deployment specification, not under your container specifications. This is your container specification. It has to be in the right place. If you put it, it's going to show you it's as per the schema. Yes, there's a schema there. It's going to validate it and throw you that error. So that's the stuff, folks. Is it clear, folks? Now, if it's clear, how do I do the changes? How do I do the changes to my Kubernetes? Simple. That is where we saw this line. You already have a YAML file. Just go kubectl apply -f. That's it. It's going to do a deployment for you. Similarly for service, I'll show you how to do it. So just go back, switch back to your terminal mode. Terminal mode, where I am currently. I'm in this working directory. So simple. What I'll do is kubectl apply -f deployment.yaml. That's it, folks. So just apply it. Done. The deployment is done. You want to see the number of pods. You see that the pod is running. Awesome. We were able to get the same stuff which we did it with kubectl, create, deployment, all those things. Here it is more declarative. So I mentioned that, and I can track what is the stuff which I'm going to which I have changed. So let's just wait, go back, look into our workloads and see. So it is there, it is deployed. Now, without doing any further changes to your YAML file, if you still try to run it one more time, it's not going to say anything. It's going to be saying you have not done any changes. There's no change needed. This is a very cool feature, right? If you do kubectl get create deployment, if you by mistake you ran it twice, it's going to run it twice. But here the state is already mentioned. So if the state is not changed, it's going to say unchanged. You run it multiple times, it's going to say unchanged. But if you go and change it, make a small replica, maybe you want to have 2 replica. Now there's a change in the state. You go and run it. I'm going to have a new change, which is basically creating a new pod. So easy. That stuffs are going to be tracked easily for me. So if I do it one more time, even by a mistake, it's not going to show me anything. So it's unchanged. This is the beauty of declarative configuration, folks. So hope this is making sense. The most coolest feature in your Kubernetes, and this is the best way to do something in Kubernetes. Now, as usual, you have a deployment. Now, how do I expose it? So you have to expose it to the outside world, right? So you need to create a service. Now we know how to do it in the UI. We know how to do it directly with a command line, which is kubectl create service load balancer. But how do we do it via a declarative or configuration? Simple. Go open your editor. Open your editor. So let me make sure I'm in this right folder. Yes, click on this folder, file. Let me give a name like service.yaml. YAML is very important. Service.yaml. There's a file. Do control space. It's going to give me some suggestions. The one which is interested for, but the one which is interest for me is Kubernetes services. Same style. Everything is going to come automatically for you. Now let me just use the same name, hello. When I use this hello, it's going to show me this is what you have a configuration, and the type of services. If I just mouse over on it, right, we don't need to remember everything. It shows the available options are cluster IP, node, port, load balancer, and external name. Cluster IP is the default. So if you don't mention it, also defaults to cluster IP. What is cluster IP? We'll explore it at maybe in tomorrow's class. We have not come to that stage yet. So what I need is load balancer. That's what I've been using all this time. So I'm just going to remove this, type control space. It's going to show me the suggestion. I don't need to type anything, folks.
load balancer came up. And this is an important one. When you are exposing something, what deployment you are exposing, so that connect has to be there. So if you see here in our deployment, we mentioned the label, it is hello. So by that label, it's going to know the service which I'm going to expose is this container image, or this pod is what I'm going to expose it. This label is going to play a major role. So label selector. So in your service, you are going to mention the same label, hello. Now you want to expose it. So the target port is your container port, and port 300 is what is the port on which your load balancer is going to listen on. So you can keep it as 3000 if you want. You can make it as 80 if you want. If you make it as 80, you don't need to mention any port. Basically, like how we were accessing previously, this one, you're going to get the same style. So that's a small change. Just change this to 80. Everything is going to be automatically there. Now, how do I apply it? Same option. Just go kubectl apply -f. So you don't need to remember so many commands. Kubectl create deployment, create service, all those things. So easy. Go back. If I see the files, it is there. Minus apply. Done. Now let me just see whether the service is up. So if I do svc, so I have my deployment, my service created. Let's just wait for a couple of minutes to have an external IP address. So easy, right, folks? So for learning those commands, it took long time for us. Now in 10 minutes, we have a deployment, we have a service, everything is there. So easy, right? I'm really a fan of this one. So easy. You don't need to remember everything, and that with this editor, it becomes so easy for you to do it. So let's just wait for a minute for our IP to come up. Okay, we have an IP, a new IP address without meet. Okay, I have to do Control C because in a watch mode, I cannot copy it. That's what I see it. If it's possible, it's okay. Done. So just check it, folks, whether it is working. Working. It's working. Now, what we wanted to do was something like this only, right? So if I just go a couple of slides back. So create a cluster, we created it in command line, we deployed it, we exposed it. Now you want to scale up, scale down, we can do it. To create a new version, we can do that. I'll show you that. But the key part was using a declarative approach. You mentioned it's going to create it for you. Instead of running these commands, which it's very difficult for someone to remember. So power users usually use this if you want. But the best approach I would say is to always use something which is declarative configuration. So you saw that value by yourself, I would say. So now what I will do is I have my code, all my configuration in this. Now I wanted to keep a track what I did last time when I did the deployment. So what I will do is, because it is a version control system, I can do a commit git status. There are two files which has not been committed to my repository, source code repository, like your GitHub. So why we need to have a GitHub? We can track the changes, what you have done in the last deployment, what you are doing in the next change. All those things you can track it. That's way this configuration is going to come handy. But how can you keep those that kubectl commands which we have seen previously? It's difficult to keep it in a version control system, right? What change you did, nothing, you can track it. But here I can track it very easily. So how do I commit my changes? Git deployment service. These are the files. Please add it to the repo. So then commit it. I'll just call it as first commit. And if you don't understand the Git commands, no worries, folks. This is going to be done usually by operation people. So if you come from the Git background, like you work on scripts, you keep the script in a source control, this is going to be handy. I would recommend you to use this. It's going to be only 3 commands. So not a big deal mastering it. Add your files, commit it. Once it is committed, do a git push. That's it. The data is, the 2 files are pushed. Now I have a configuration and I can also know what is the tracking. I can do the tracking. So if I just go refresh this page, I will have this file committed by Mahesh at so and so time. And what is the configurations which you have? So 2 replicas, this is the version, this is the configuration. Service wise, I have these things. Now there's a requirement which comes. Can we have a newer version deployed, which is 3.0? Good. What you can do basically, when we learn CI/CD process, the person only comes and edits the file in the source code. That's it. Automatically, it can be deployed in your Kubernetes cluster. That kind of possibilities are possible easily using continuous integration and deployment. We will do something similar in our module 7 at a later point of time. Now, since we don't have set up CI/CD process, what I'm going to do is manually go and change it and do it. So I can edit it here. Let me just edit it here. Can I edit it? So I can edit it or do it. So let me just edit it here. Can I edit it here? Trust. I never thought I can edit it like this. Oh, it's going to clone and okay. So let me just zoom this a bit. So now I wanted to do this change. So change this to 3.0 and I want minimum 3 replicas running. Now I can keep this track easily. I can keep this track easily and start working on it, commit the changes, then apply it. So that way I have complete capture of what needs to be, what was done, who did it, everything. So now if I do git status, you see only one file is changed. Only one file is just commit it so that you can keep a track of it. How do I commit it? Git add deployment git commit -m. The message which you are going to say is uh, deploying new version. New version. Push it. If okay, it is pushed. Oh, is it pushed? Let me just see it, folks. No, it is not pushed. Why it is not getting pushed? Git status. Okay, let me check why it is not getting pushed. But I have my changes. I have my changes. You want to apply it? What's going to be the command to apply this change, folks? So the command is going to be the same thing. Apply, kubectl apply. -f deployment.yaml file. That's it. You just apply it. You should have basically watch kubectl set get pod. So currently you have 2 pods running. What's going to happen? I need a new version, meaning it's going to just drop these 2 stuffs, terminate it, create a new 3 replicas, which is a newer version. That's it. So just apply it. I guess it is not changed here. 1 minute, folks. I'm in the wrong folder if I'm not wrong. I'm in the wrong folder. I'm in the wrong folder. Okay. I'm in the wrong folder, sorry. So when I cloned it, right, it created a folder called Cloud Shell Open and all. So slight confusion there. kubectl apply -f deployment.yaml -f. And you can also have multiple files like this. If you want, you can do this also. This is also possible. Or you can go one level out and do it at your folder level. So meaning you can do out, can go out. You have a configuration. You can do something like this: kubectl apply -f GKE, like this. So whatever is the services deployments which you have, all those things are going to apply. Now services, there's no change, so it's going to be showing like nothing is changed. But deployment, there's a change, it's going to get updated. So you see this deployment configured, but services nothing. It's going to be there. Now my older stuffs are going to be terminated, and I'm going to have a new version, and I should be able to serve it with 0 downtime. So if I just go refresh it, I should see it. That's it, folks. So simple when you're doing with declarative approach. And all the changes are going to be tracked in my version control. So that's easy for me to understand what was changed, basically. Let me just stop it here for any questions on the declarative approach. Any questions on this, folks? Folks need a response. Which is widely used? Declarative. Commit, I'll show you that part. So I'll show you that part. Declarative is the one which is used extensively. I'll just show you the commit part, why something went wrong there. I was also not sure what went wrong there, but let me just see this. It should have shown me the details here. Let me just go back and see, have I committed it? The commit has not even come. The second commit which we did, it did not come up. Let me just see that part. What went wrong? What went wrong? Let me just check it out. Oh, okay. I understood it. So the path was this one, folks. Okay, this was the path. So I should have committed the changes here. So if I just slightly zoom this, I'm not able to zoom this. So if I do git, the sequence of steps. So, okay, let me show you the sequence of steps. So if I do git status, it's going to show me what has been changed. Is there any change which you have done, basically? So where is my change, folks? Let me just close this. Let me show you the sequence. I'm here. So you go inside your deployment. So assume you do some changes. To your stuff. Now this Cloud Shell is something which you can use, or it could be a local system where you all do this. Can you please do, I'll show you the PWD. So I'll just do the PWD. So the place where it cloned, it is wrong place. So it's not working. So if I do print working directory, I'm in my GKE configuration, the one which we cloned. So I have done some change here. I've done some change. 3 replicas is what I wanted, and the version which I want is 3.0. Now if I do git status, it's going to show there's one file which is modified. One file which is modified. So how do I commit it? So the way you do it is, it's going to show that command at the bottom. Do git add and then git commit. That's what it indicates, Kumar. So just do git add the name of the file. Done. Now if I do git status, it's going to show it is in track. Now commit these changes to your repo. So for that I use git commit -m changed the version, or changed to version 3.0 with 3 replicas. Done. Then let me push these changes to my repo. It is now going to reflect in my source code repository. So if I just go here, refresh it, I'm going to have 2 entries. Now I can track it very easily, right? See what was the one which was done in my first version, and I can compare it. So if I just go here, in the second commit, 2 lines were changed. Replica was changed from 2 to 3. The version was changed from 3 to 0, 2.1 to 3.0. I can easily manage everything in my source code repository, and I deploy it whenever I want. Just do kubectl apply. That's it. Makes sense, Kumar? Anil, so the print directory cleared it. Looks like the last time we made changes, it was outside the folder. Yes, it was outside the folder. Something went wrong. So something went wrong, basically. So this is the way which you should use. Now, the next thing which we are going to do is, all these things which we did was manual. I change the code, I commit it, push it, and again need to do kubectl apply. But in module 7, we are going to do CI/CD process where you just need to commit the code. That's it. Commit and push it to the repo. Then doing kubectl apply, Google is going to do it for us using a tool called as Cloud Build, which we have learned to some extent already. So that's going to be automated deployment there. So that's going to be an ultimate one there. But now we'll not discuss that because we are in compute engine or compute options. At a later point of time, we'll look into CI/CD process. All right. So if this is clear, we'll move on to our next stuffs. So we saw how to deploy a YAML, how to deploy, a service, a deployment, all those things with one single command, kubectl apply. Now, a little bit of a tip about little more. We talked about deployment, pods, all those things. How do I connect pod, deployment, all those things? So I got this image from internet. It was really nice. So I thought, let me use this and show you the concept. So all these times which we were doing was, the whole aim was, we have a container, we need to just deploy it. We did not go into the details of about deployment, the kind of object which we were using. We never went into the details of it. We never went into the details of the services, the types of services which you have, load balancer, cluster IP, node port. Now let's explore that. Okay, so first let's go with the deployment. So usually the deployment, it's a kind of an object which you get in Kubernetes, which is going to basically have an option to wrap your pod. Pods are wrapped inside a replica set. Inside the replica, and the replica set is going to be wrapped inside a deployment. Now it's going to be a high level construct which keeps changes of any updates, and if something is changed, it's going to update that automatically. It's going to be like a contain, I would say like a wrapper or a high level construct for your pod. So at the end, the pod is the one which is important. Then if you were to look into the replica set, how many replicas you have created. So you can track it from your replica set, and high level wrapper or deployment, if you want to see, that's your deployment part. So the topmost stuff is your deployment. Now it may look little difficult to grasp, so I'll try to show you a small demonstration on deployment, replica set, and pods. So first in the UI, then in the command line. So how these are: pod is the lowest one which you have, and you can deploy a pod directly on a Kubernetes. You don't need to wrap as a deployment. That is also possible. Let me just show you that part. So to make that clear, let's go back to our console. So back to console. If I go to my workload, whenever you come to workloads, right, look at this type, folks. What is the type? The type is a deployment. It's a deployment. Now, if I click on this deployment, what I get is basically the deployment details. The deployment details. Now, if I slightly scroll down, I get something called as replica set, which is going to manage all your replicas, all those things. So the name of the format in which your replica set is going to be there is the name of your deployment hyphen some alphanumeric characters. So if I just go here, this is your replica set. Now, when I click on this, it's going to show me my replica set details. You see that from pod details, it became replica set details. Now, in this replica set is only you're going to mention how many replicas you are going to have. 1, 2, all those details are going to be there. Now, if you go inside the replica set is where you are going to see your pods, the individual pods. So if I click on one of this pod, it's going to now show me the pod details. It's going to show me the pod details. So this is how the navigation goes: deployment, replica set, and a pod. This is how it goes. Now, what is going to be in pod? What is the configuration which is going to be there in pod? You can look into your YAML. You can look into your YAML. This is becoming a little difficult. Let me just show you the stuff. There's lots of auto-generated stuff here. I would suggest, let me use my console, a terminal. This is little difficult to show. Connect back. One minute, folks. I just wanted to show you that part. Let me connect back. What happened? So command line looks better for this part. So if I just do kubectl, the way to navigate is deployment. Then inside the deployment, you will have a replica set. Inside the replica set is going to be your pod. Now, how can I see that in the command line? Is going to be something like this: deployment, comma, replica set, comma, pod. Deployments, you can call deployments, replica sets, pods. Now you look at the pattern, folks. You'll get it very easily. So you have a deployment, then you have a replica set. There is two replica set because we have created two versions from 2.1 to 2.3. So if you want to revert back also, you can easily revert back with your replica set. So currently there is no pods running. You have a second version of your replica set where 3 pods are running, or 3 replicas. Then look at this one, ID. It is your same ID with some suffix, and these are your pods. Now you can see that how the hierarchy flows: deployment, replica set, or RS usually in short, then your pods. If I do this style, PO, fully in the short form, rs is going to again show me the stuff there. So again, it's going to show me. Now, replica set is going to keep all your version changes. If you want to revert back to this version, you can go and revert back easily. So that's where the versions are going to be tracked also there. And one important stuff which I wanted to show here is just copy one of your pod. Let me put it here. Get one of your pod details, copy one of this pod. Now run this command kubectl get pod, the pod details -o and YAML. This is going to give me the YAML file. So hit enter. Hope the configuration is very simple for me to explain. They made it a little complex. So when you are looking at a pod, right? When you're looking at a pod, this is difficult, folks. Let me just use this one. Sorry. So if I go to my pod, look at the YAML. This is replica set. My bad. 1 minute. Go to replicas. Go to my pods. So I'm in my pod details currently. Now, if I look into my pod, the YAML configuration, in this configuration, you will not have any details about your replicas. How many replicas you want, all those things will not be there. Only the pod specification would be there. What is your pod specification? Basically, if I just search for replica here, replica set, that's it. No other presence. So what I will have is only this specification. This is my container specification, nothing else. This is what I need. This is the image, this is the configuration, this is the specification. That's it. Now, when you go one level up from pod, sorry, from if you go to replica set, in your replica set, basically, if I go to my YAML, in my replica set, the YAML, here I will have that information of the replica. So if I just do the same thing, replica, 1 minute, I am making something wrong. So replicas, they made lots of changes in the UI, folks. Okay, so when I go to my replica set, I'll have my replica details, but in my pod details, I'll not have this replica details. Now, what is going to be there when I go to my deployment is where how you are going to deployment, the strategy of your deployment, rolling update, or there is something called recreate option. That is what you are going to see in your deployment. So if I go to my deployment and the YAML details of it, I'm going to see some specifications, which is specifically to your style of deployment strategy. So different configuration or different like pod is going to have just the pod specification. Replica set is going to have pod specification plus that's replicas. Your deployment is going to have the strategy, how you are going to do it. This is going to be very easy if we can show, if I can show you in this editor. I understand it's going to be a little confusing. Let me just repeat this and use this new option. This is not the one. I don't need this. So if I just go here, I'll create a new YAML file, folks. New YAML file. I'll first call it as pod.yaml. Pod.yaml. Now use my control space. Look for the pod template. Pod template. Now look at this. Do you have any configuration details about your replicas? You'll not have it. You'll not have it. And even if you try to put it, it's not going to work. So if I just put it here, because there's a validation, replicas, it's going to throw me that error. So you will not have any replica details in your pod configuration. That's first thing. Now if I create a replica set rs.yaml and do control space, let me see whether I can have a replica set configuration. A replica, no, I don't have it. I don't have it. I don't have it. Okay. But I can just do deployment. In deployment, when you will have the strategy. So let me just do this. So if I just do deployment one more time. So in my deployment, I can have few specifications. I can have few specifications like the strategy. What's your deployment strategy? So whether you want rolling update, then in that, what should be your maximum surge? What is maximum surge? I'll talk about it. Maximum availability, all those things. So I can have this kind of a strategy. So in my deployment, I will have this. In my deployment, I'll have this configuration. It's going to be valid. Then in my replica set, I can have replica details. In my pod, I can have only the container specification. Let me just wait for here for any questions, folks. Is this clear? So basically there is a 3 layers here: pod, replica set, and deployment. Replica set, these days people don't use it heavily because they package everything in the deployment itself. They mention the replica and then do it. If you ask me, the way you have to do it is first create a pod, then create a replica set, then create a deployment for it. But now with deployment, you can package everything and do it. Yeah, is there a question?
So Mahesh, what exactly we are achieving with this actually?
Okay, what we are going to achieve, that's going to be a good question. So let me just show you. Now, what we are going to achieve is, let me just remove this content. Pod. So let me select pod. I'll call this as hello pod. And the image which I want is the same image. So what we are achieving by doing all these things, let me just show you that. Version 3.0. Version 3.0. That's it. Now this is my pod specification. There's no doubt in this. Simple, it's auto-generated. We just gave our pod details. Nothing else. It's not a deployment. The kind of object, if you see, it is deployment. Now, what I will do is, I will just do kubectl. I'll just do kubectl apply -f pod.yaml. Now it's not deployment, folks. It's a pod. It's pod. So it's a pod is what which we have deployed now. Now if you go to your console and look into it, you see totally a different view, and we'll understand a deployment and a pod difference by doing this demonstration. So if I just minimize this thing, refresh it. Okay, I cannot schedule it because of insufficient stuff. Now what I will do is, there are 3 replicas already, so I'm just going to make it as 2 and give some space for me to run this. So if I do vi deployment.yaml, so I make it back to 1. I do kubectl apply -f, done. Now I should be able to deploy this. Let's just wait. It should get, it has now enough compute option resource. It should get provision.
See, that's what Mahesh. Now, whatever you just done, right? kubectl apply minus f deploy that by a YAML file. And I mean, I didn't understand what is the difference between this and that pod dot by.
Wait, I'll show you that.
Yeah.
I'll show you that.
Okay.
So now the same command, we deployed a pod and we deployed a deployment kind. So this is what you see as a difference. Now, what is this difference going to make a huge impact is, now this is deployment, this is pod. What I will do is go run this command, watch kubectl get pod. I'm going to run it in a watch mode. This is your pod which is deployed via a deployment. So it is managed or it's entirely controlled by your deployment. Meaning if I go and delete this pod accidentally, delete pod, the complete name, I delete this accidentally, what's going to happen is it's going to get terminated, but immediately a new pod is going to come up. The reason is you have mentioned it in the replicas. The desired state is I have to have always one. It does not matter for me what you are going to do. You should have one replica running. So this is now controlled by your replica set and deployment. So this is going to be self-healing capability is going to be there. Self-healing capability comes with your deployment. Now, if I try to do the same thing for this single no pod, it does not
Then
have
it
any
will not.
self-healing
It will not
capability.
create. Yeah.
It will not even
Okay.
come up. It will not even come up. So that's the whole reason why you need to wrap it as a deployment. The self-healing capability is going to come. So now if I
Thank you
just
very much,
try
Mahesh.
this, yeah. So now if I try this, deleted, bye-bye. After it goes, that's it. It does not come back because you have not wrapped it. So deployment is going to have a self-healing capability, but your pod, just the pod will not have it. So it's always recommended you don't create a pod like this, because if something goes, something crashes or it does not, it cannot come back. But if it's a deployment, part of your deployment, it's going to always have that self-healing capability which is mentioned here. So the self-healing capability is going to be there. So deployment, replica set and pod is a better choice when you are going with it. And usually people now put replica set in your deployment itself. The replicas, all those things, part of your deployment itself. So this is going to be a better approach when you are doing something in Kubernetes. Let me stop here, folks, for any questions. So the self-healing capability is going to be there with only with your replica set or with your deployment, because deployment replica set is going to be wrapped inside a deployment. Any questions, folks? Maybe the last 20 minutes was little confusing, so just want to stop here for an explanation if something is not still clear. Don't use pod. Always have a deployment which is going to have the pod specification, the replica specification, and any strategic way of deploying it, rolling update, all those things.
So, Mesh, at any particular circumstances, do we need to manually create pod?
Sometimes for testing, right? Tomorrow maybe we'll do that. For some testing purpose, you want to just have a small standalone pod. For example, in this Kubernetes cluster itself, right? Say for example, if I just go to my this thing, cheat sheet. Assume from your kubectl, from your cluster, you want to run some gcloud commands or something. So what you can do basically is in some scenario, you may want to run a standalone pod with something like this. Let me just copy this. So what I'm going to do now is I can create a pod using the option like in a declarative way like this, or in an imperative way like this, where I create a slim version of Cloud SDK. So this is going to be deployed in my Kubernetes cluster as a pod. Now what I can do with this option is, if I were to do some gcloud commands, all those things, I can use this. So it's a standalone pod in my cluster. So sometimes for testing purpose, this is going to be helpful. If you are not able to debug, have a pod running like this, go check what's happening there. So that's where an individual pod could be really helpful. Mangesh.
Okay, thank you.
Yeah, tomorrow we'll do a demo, so which is going to help you on understanding how we are going to do this part basically. So now I'm in this pod. Now if I just do gcloud, I'm in a pod, folks. I'm in a pod. I'm in a pod and I'm running these commands. So if I exit and do kubectl get pod, I see a pod name. This is my pod, which is running my Cloud SDK. I am running my Cloud SDK in a containerized form. So that is what you see basically. So that's your deployment, replica set and pods. People don't talk much about replica set these days. The only thing is that I saw some official documentation in Kubernetes page. So in deployment itself, they put everything. So it's going to cover everything. So they don't specifically create a pod, then a replica set, then a deployment. So in deployment, have everything and deploy it. That's it. Tomorrow, when we come back, we'll explore more about our deployment files, where we are going to talk about some parameters like ruling update, max search, all those things. How we can look into those various configuration details, replicas, where should you put it, where you should not put it, all those details we'll see, because I showed, right, you cannot put it in a container specification, the replica part. So how do you know where to put it, all those details? There's a small trick which we can use to know that. So we'll explore that in tomorrow's session. So if there's any question on what we did today, let me know. Happy to answer. Any questions, folks? If the last part was not clear, no worries. I'll repeat it tomorrow once more. The last 20 minutes or so. The importance of a pod and the importance of a deployment. The deployment replica set are self-healing capabilities. Pod is not self-healing. Simple. If you remember that, that's going to be good. So I showed you that self-healing capability there. So if it's still not clear, let me know. We can redo it tomorrow again. Any questions, folks? All right, so was a long session is what I feel. Okay. All right, folks. If it is, there's no questions. Is there a question? Somebody
No,
unmuted.
I just Vivek here. Just a
Yeah.
general query actually.
Yeah.
I don't know. It would be too early, but to ask this question. But I just want to understand: is there any, I mean, way or material that we can practice? Which kind of questions we can come up during interview for GCPs actually?
I don't have a ready-made thing. So only when I look at any topic, when I'm talking, something strikes me, I usually talk that. I don't have a ready-made one. I have to sit and create what and all. So I have to go through all the slides. Then whatever strikes me, I usually do. I don't have a ready-made stuff, Vivek.
Okay. Actually, thing is that no, I'm learning GCP from almost more than 6 months actually. So I've started preparing for interviews actually. So during this
Best
preparation,
way I would say, the best way I would say is uh,
right?
standard one. So 2 or 3 interviews will go for a toss. So what
Yeah.
was not answered there, you try to capture those things, learn those things. That when you are learning that, it is again going to lead to one more few stuffs. So that way the chain reaction is going to happen and you can learn more stuffs. That's what I would suggest. That's going to be the best.
A reaction, I mean, every action has a positive equal and opposite reaction wala hai. Once I will come up with the question, then I know I need to study this, I need to study this also. Because, you know, most of the people ask about migration. What I can know, everything is practically, I can be studied via courses and online courses, but migration is the topic where everybody lacks. Means they start asking real time scenario. Have you ever involved in migration? What tools and how it works? Just reading theory, it's not possible to explain anybody that, so yeah, I mean, I was involved, or I have something experience. This is the topic. Actually, I had given one interview in which they started about migration. Nowadays, you know, multi-cloud culture is there, no? So people ask, they leave everything. They start asking question about migration, how you can manage migration, how you do lift and shift, how you migrate your Kubernetes resources, and some complex material. I know there is a topic, but it is, and that is the last topic in our training. But thing is
So
that
thing is that the way I usually take this do is only if you are blessed to go to a data center and do all those things, then on-prem to GCP migration kind of a stuff you can do it. So, but I would say the only migration which you can try yourself is from other cloud to GCP. So if you create a free trial account in Azure or free trial account in AWS, run some kind of Anthos for migrate or migrate for compute engine. That way is what you can do basically. If you, because if you feel it's everything is theoretical, the only way to do something practical is one cloud to another cloud. On-prem to GCP, if you are an individual, I would say you will not be able to do it because you cannot get access to a data center. So cloud to cloud migration is what you can try maximum in this, so that you get an exposure. Now, a better way to handle this kind of questions in interviews, you can say very blunt, on-prem to GCP I have not done, but cloud to cloud I have done. So you would have done this practice, so you would be in a position to answer those things. AWS to GCP, it's a valid one. You can try it yourself. You can try a free trial account. 30 days is what I guess AWS gives. 12 months they give it for some free options are there. Leverage that and do that. That's going to be the approach I would say.
Okay, just need some path to move on. That's why I keep on asking some question. You may suggest something which, like you said, na, AWS to GCP. It's quite good. I never thought that I could have done this earlier.
You can do that.
Okay. Yeah, thank you.
I have done it. I have learned it actually doing that migration. There's one demo also in my video in my channel, which is now deprecated. A cloud endure from EC2 instance to compute engine. I migrated it. So there I use a tool called as cloud endure. Now we can use something called as Velostrata, which is now renamed as compute for migrate.
Okay, sir.
So,
thank you, sir.
Yeah. Any other questions, folks? Happy to know, Anil, it was helpful. So. All right, folks, if it's no more questions, I'll stop it. All the stuffs are updated except the bookmark. I'll update the bookmark page or HTML page today. You can look into the bookmarks. The recordings, I'll upload it in next 3 hours. So recording should take 2 hours to process. I should upload it right away after that. See you on tomorrow's class, folks. Thank you. Bye.
Thank you, Mahesh.
Thank you. Bye. Thank you. Bye.